Welcome to the first day of peer review presentations for Geog 596A, our Fall 1 term, 2021. I'm Jim Detweiler, faculty lead for the Geospatial Programming Certificate. For those of you who don't know me, we have 7 presentations today. Just a few reminders. Presenters are going to have 25 minutes to give their talk, followed by 5 minutes of questions. If you have a question for a presenter, please enter it into the chat box. And you might consider typing your question into a separate text editor, then copying and pasting it into the chat box when the presenter wraps up so you don't distract them during their talk. Presenters, please read the question out loud so that anyone who's watching the recording will know what you're responding to. 596A students, we're expecting you to provide constructive feedback to the speakers. Others who are attending are invited to do so also. We have a link posted to the peer review form in the chat box, thanks to Beth. Without any further ado, first up we have MGIS student Scott Kozicki, who's going to talk to us about using nighttime imagery, aerial imagery, to detect COVID lockdown compliance. Scott, are you all ready?
Yep, can you hear me?
Yes.
Okay, should I be sharing my screen then?
Yep, go ahead and share your screen.
Okay.
Looks good.
Cool. There we go. Okay. So I'm going to talk to you guys about the use of VIIRS nightlights imagery to detect COVID lockdown compliance. So some background: VIIRS, also known as Visible Infrared Imaging Spectrometer Suite, is basically this NOAA satellite that has a bunch of different bands that's really going after weather data. But one of these bands is a panchromatic, what they call a day-night band, and they'll collect imagery of the entire globe every day in both the daytime and the nighttime. So this nighttime data, there have been plenty of studies out there where they really go after correlation of, there's different correlations of the radiance of this light on the ground to GDP. So I was kind of looking at this nightlight data and trying to figure out what can I do different than this GDP stuff. And Pando's kind of threw out there a great idea of everyone's favorite topic in the last couple of years, COVID. So we want to look at how has the COVID response in all these different countries, primarily in Europe for this study, just to kind of constrict the area. Can I minimize this? We want to see how that response is seen in the nightlights data. So the big correlation that everyone's talked about in multiple papers is this nightlight data is a strong correlator to GDP. So I think you can kind of throw out a number of different reasons of why that is happening. And one of those assumptions is in countries where you have higher GDP, people are going to be more likely to be out at night, either, I don't know, just going to stores, going to restaurants, doing nightlife activity. So if that is something that is one of the major contributing factors to why areas with high GDP have more light, we'd expect to see a decrease of that with COVID. So we're kind of going really into a finer grain of what does light activity actually mean at night, and is this something that's measurable with different levels of lockdown during COVID. And since we all know kind of during COVID, a lot of countries had very different restrictions that they set in place. So by sampling different countries with different restrictions, we kind of see how that response differs between each of these countries. So the value of this, honestly, this data is not used as much as I think it could be. You've got these nightly imagery collections of the entire world. And really everything I've seen in literature is it's just looking at imagery versus, or the amount of radiance versus GDP, or just other very small nuances of that same problem. So I'm looking to kind of push this into what else can we glean from this data. Also, you can have similar situations of if there's another outbreak that happens, maybe just in a certain part of the globe, by having this data out there and looking into this problem, you could potentially get some more insight and kind of extrapolate these results into other areas. Also, this is a non-intrusive method for detecting something like this. So instead of having people on the ground and actually trying to get these measurements, you've got the system that's already collecting every single day, and you can just download the data and extract it from there. And also going back to the whole GDP thing, by exploring this further, the model for kind of detecting GDP isn't perfect. So by adding another layer of into this model of what actually goes into that GDP calculation, you kind of get a finer grain of what do these nightlights actually mean in relation to GDP or other things. So you kind of are able to refine that model even more. Okay, and kind of the main thing that we're going after here is just because a government issues certain restrictions, that doesn't mean that the citizens are going to follow it. So your classic example here are countries like Denmark and Germany. Historically, the citizens of those countries are very compliant with government regulations. So if they're told what to do, they kind of say, no questions asked. Yes, let's do that. This is for the good of the country. Let's all sit in our house and make sure that we do something about this virus. Conversely, you have countries like Spain and Italy. I'll throw even Greece in there, as Panos is kind of thrown out there in many of our talks. Generally, these citizens of these countries don't always listen to the rules. So the government may tell them to do something, but they're not so willing to do that, and they're going to make their own judgments based on their own decisions. So this leads into the design for this study, which is 2x2 research design. And the idea here is we look at two seemingly independent variables of lockdown severity and trust in government, and we take samples from each of the intersections of those. So looking at this chart on the right here, we're basically going to say, hey, what countries have low trust in government, what countries have high trust in government, and then break those out even further, saying which countries have low trust in government, low lockdown severity, high trust in government, low lockdown severity, low trust in government, high lockdown severity, and high trust in government, high lockdown severity. I hope I got that right. And by looking across that board, you're able to look into those two variables independently. The way we do this is by breaking out those countries and then looking at the light levels across those countries. The data for this, we basically have three sources right now. There is the Beers Nightlights, which is obtained from Colorado School of Mines. I'll go into this a little bit, but basically what they've done is they've taken all of these nightly images and they've converted them into a monthly mosaic. So anytime you take an image at night, you've got issues with that image. You're going to have cloud cover that's going to be rolling over. You could have stray light due to the sun at different parts of the year that's entering into the telescope. And you also have major impacts from lunar illumination. So if you think about a new moon, you have no light that's coming from the sky that's hitting the ground. So all the light that you're sensing in the image is really coming from the ground for the most part. But if you think about full moon, you have a lot of light that's bouncing off the ground and coming back in. So you're going to get very different amount of light coming back between a new moon and a full moon. So they're able to correct for this in the monthly mosaic due to the monthly lunar cycle and give you just one static image across the globe. The next two, which I'll get into in a little bit more detail later, is a COVID stringency index. So this is compiled by a website called ourworlddata.org. And this basically gives you a single value of countries across the world and how severe their lockdown restrictions were at different parts of the lockdown. So they actually provide an index for every single day from, I think it was the beginning, it was maybe like January 2020 up until today. And they give an index of how severe are the lockdowns in this country. And the other one is trust in political system from Eurostat. And this isn't exactly what we really want to go after, since the main thing we were looking for is how much do citizens in a country, or how willing are citizens in a country to follow the rules? And the way we kind of extrapolated that is countries where citizens trust their political system are more likely to follow the rules, since if they trust the political system, they trust the rules that are in place. So we found this data where there are a few different trust indices, and the trust in political system we used as the definer of how well are citizens willing to follow rules. Okay. So VIIRS data, my background is imaging science, so I can't talk about an imaging system and not go into some specs. So for many of you, this spectral response on the right was probably completely meaningless. For me, I have to have this in here. So VIIRS itself has a bunch of different bands ranging from your visible all the way out into, I think it goes up to like 2.2 microns, something like that. either way, they've got a bunch of different sensors, and the one we care about is the day-night band with a spectral response seen here on the right. So it is mostly a visible near infrared. Honestly, most of the response is in the near infrared, but for nighttime imagery, this is perfectly fine since it picks up your like all of your like LED and your high pressure sodium lights as well as your incandescent lights. Um, the pixels are quite large on this sensor. You're looking at a resolution of 200 meters to a kilometer. So we're not talking about actually seeing details in cities. We're looking at city blocks or larger areas to actually aggregate all the lights. So any individual pixel in this data covers quite a large piece of ground. Okay, now the fun chart of this presentation, looking at the COVID stringency index and the trust in political system. So the stringency index is actually based on 9 different measures. There is school closures, workplace closures, cancellation of public events, restrictions on public gatherings, closures of public transportation, stay-at-home requirements, public information campaigns, restriction on international movement, internal movements, and international travel controls. So all these I think are important going into a metric. The only one that I think if I could tailor make this is the public information campaigns. I don't know if that is quite as important since we're really looking for preventing people from moving and going outside. But I think given all of these together, I think it's a fairly good metric. And what I've done here on the right is taken all the countries in Europe and plotted their stringency index and then the trust in political system. And it's important to note that the stringency index is based on a mid-April date. I actually don't have the date off the top of my head, but I want to say it's like April 10th or April 17th or something like that. And once I laid this data out, in order to fit into the 2x2 model, I basically took the median value for each of these indices and said, if a value is above that median, it is high in that category. If it's below, it is low. And then was able to break out into these high, 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 low, high, and low, low categories. And one thing you can note, I think it's pretty obvious right away, is there seems to be a pretty strong inverse relationship between these two indices. So it almost seems like countries where the citizens don't really trust the politics, in order for the government to actually get people to do what they want, they have to enforce stronger policies than in countries where citizens are more willing to follow the rules. Okay, so going through for high, I want to right now go with Romania. This seems like a best choice out of each of them. It's got the highest stringency of the group, tied with Malta, but Malta probably would not be a good selection given that it's this small island country. So it may not behave the same as the rest of mainland Europe. Next for the high-low, I want to go with Spain. And this I think is a good example since large country, so you should have a lot of data you can gain from different cities or parts of the country. And it also has very low trust in the political system. The other one I kind of wanted to go here is Italy, just because it has even more stringent controls, but decided not to go with this because that was one of the first countries hit with COVID, and they basically had the restrictions front loaded compared to other countries. So the timeline of their lockdown doesn't coincide with many of the other countries. So it probably won't be quite as apples to apples as the other countries. For low high, I went with Denmark. And this one was partially when I first started doing research into this problem. I saw quite a few articles that were highlighting Denmark on how good of a job they did. And a lot of that was actually just due to the social nature of the country, and people are just more willing to follow the rules there than many other countries in Europe. So they did quite well with COVID because of that, despite the fact that their stringency index is actually quite low compared to many of the other countries. And lastly, for low, I went with Latvia. And this is mostly because the other two that were up there were Iceland, which again, like Malta, probably isn't a great choice since it's moved away from the rest of mainland Europe. Was also Bulgaria. I did a plot of the stringency versus time, and Latvia and Bulgaria were basically like neck and neck with each other. So I think if there's something that pops up while doing the research. Where Latvia doesn't make sense, I could probably switch to Bulgaria there. But either way, I think it's a wash of which one you choose there. Okay. Going on to the methodology, this is just a basic outline of what I'm looking to go through. So basically the idea is I bring in these VIIRS data sets into something like QGIS and overlay a shapefile onto that. And I want to do a shapefile for the entire country and then individual cities within that country. Since when I was doing research into GDP and nightlights, one of the studies that popped out, actually there were quite a few studies that popped out, they basically showed that the correlation of GDP to light activity was much higher in cities than it was in rural areas. And I think intuitively this makes sense because in rural areas, your GDP is more likely to be driven by agriculture, and agriculture doesn't generate lights at night. Where in the cities, you have a lot of your industry is generating lights. So I want to take the light data from the cities in the country and the entire country just to see what the two different samples look like, to see what makes more sense for this study. And then for each of those shapefiles overlaid onto the light data, I'd pull out the radiance for each of those subsections of the imagery and calculate a radiance per unit area of the shapefile. And then using that, I compare between the countries and then compare between the city and the country data to see what makes sense across that whole low, 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 high, high, low, 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 or high, high comparison. And I think that's all I got. And these are the references for the data sources.
Okay, thank you, Scott.
Okay, are there any questions? I see a hand raise from Steve.
Hi, I had a quick question. In terms of the light source, do you have any data or research that would possibly indicate availability of fuel sources for electricity in different countries and how that might have been a factor in terms of how much light you're seeing at a given time? I'm looking at supply chain impacts from COVID. I know in home construction, it affected a lot of different areas, and I'm sure it did in certain countries too, but also certain countries will enforce use of electricity at different times depending on the availability of production capacity. Do you have any data for that kind of thing, or is that beyond the scope?
I do not have data. My gut reaction is that maybe beyond the scope. I think that may be one of those things where let's look at the lockdown versus the results, and then if stuff doesn't make sense, we can start adding more stuff in. One of the things I forgot to mention is the Our World Data website has a ton of COVID statistics that are out there. So I think that in my mind is kind of lumped in of after the fact. If there's kind of noise in the results, let's look at other data we can throw in there to maybe clean up some of that noise. And I think that's probably a prime example of something that could be thrown in there. Thank you. Stephen Robert Douglas, I think I heard you state that you discarded countries that where findings made no sense. Can you explain how it made sense or not? I'm trying to think of the context of when I said this. The contents for that may have been the like Malta and in Iceland, where these countries are separated from mainland Europe. So in my mind, they're not going to have the same behavior patterns as your countries that are more interconnected. I don't think there would be the best examples to include in the study, since they're going to have different factors that are going to impact the light levels in those countries. So I think in that sense, it wouldn't make sense to use those countries. Does that answer the question? Okay, nice presentation. So from John Jan Oliver, I'm not pronouncing his name, Walgrun. Nice presentation, interesting project. Scott, I'm living in Germany, and there actually are large regional differences in compliance, trust, and all of this, I can't read right now. And all this has changed quite a lot over the course of the pandemic. I wasn't quite clear whether regional variations were a criterion for picking the countries you decided to look at, and whether available data would also allow for doing this analysis on a finer level of granularity than country-based. This, I think, would be very difficult to grab that data. I struggled quite a bit with actually finding the trust metrics just in general. If I could find a metric that went more regional into the trust of the citizens in a country, I would definitely like to use that. But I think it's difficult to find that data. So if you know of where I could get this, I would definitely like to use this, but I don't think it would be easy to find. Is there anything else?
Yeah, Scott, I have a question. When I think about nighttime lights, I think about things like parking lots and lights on the outside of buildings and things of that nature. And I'm trying to understand the thinking behind nighttime lighting going down as a measure of how much folks are responding to the lockdown restrictions. Is like traffic from cars, does that make up a really big proportion of the lights that we see from the air? Or
I don't know if cars are going to be that big of an impact. But one thing I was thinking is like, I think the parking lot and lights on buildings is a good example of, say your business that operates, I don't know, like a downtown like nightclub or something. You're probably not going to spend the energy to have those lights on if people can't come to your club.
Right.
And I think that's the thinking there. And that kind of goes into what I was talking about early on with nightlights being correlated to GDP. Is that just due to businesses that are operating and they need these lights to be on to be operating? Or is that due to your more social nature of people moving around and needing those lights to move around and do activities? So I think the answer to your question is I don't know. And I think looking at this will help look into that question a bit more. But I did see I was actually looking for the background images for the presentation, and I actually stumbled on a website on, I think it was a Veer's website. And they actually showed a very quick snippet of looking at light data in some city in China. And they did actually show a difference between pre-lockdown and during lockdown. So I think the expectation is we're going to see a drop in light. The question is, what is that caused by?
Okay, good.
Yeah, and Steve makes a good point here. Many businesses keep their light on the exterior for security. So even if they're not operating, it makes sense to have those lights on.
Other questions for Steve? We still have some time.
I have a quick question. So just based on everything, you talked about in your project and all of these questions everybody else has, it seems like there's just, it's a really cool concept. I definitely would have never thought of it. How do you plan on controlling the scope creep, and kind of, I guess, what goals are you gonna set for yourself to be like, okay, here's my stopping point. I'm not gonna look any further into how agriculture might be affecting this, or specific regional areas might be affecting things.
That is a great question. And that's one I'm honestly worried about a little bit. I don't have a good answer to that right now. And I think that's something I should probably like draw a line with right now. I know I have an issue of when I go into projects, I just want to keep peeling back layers of that onion to kind of learn more and more about it. So my hope is I can just find a good stopping point there and not try and go too far. But no, I've not defined a good point of don't go beyond this point of scope creep. So I think that'd be good to add in. Thank you.
Okay, any other questions? Looks like you've got one from Steve M.
Scott, I'm sorry, I keep coming up with things. COVID spread rates in different countries are different, right? So they don't always have the same level at the same temporal point in time. So are you trying to capture the same level of infection rates for the countries that you're going to use for your study?
So we're not going after the infection rates. We're going after the lockdown measures of those countries. So actually, I don't think I can find that. I made a plot of basically each of the countries' stringency of lockdown. Hold on, what was it? Lockdown stringency index and that versus time. And you can see that some of these countries are at slightly different timelines. So I'm trying to pick countries that their ramp up is fairly similar, just so that their policies are the same, and we're kind of looking at apples to apples across those countries. And that was one of the main reasons for not wanting to use Italy, since yes, the infection rates were much sooner than many of the other countries, but because of that, they started ramping up their stringency much sooner. So it's really the stringency we're going after, and not the actual infection rates.
Okay, well, Scott, you've been on the hot seat for a while now, so I think we'll let you off. Thank you for an interesting presentation.
Cool, thank you.
And next up is George Adams. And George is going to talk to us about his development of a user configurable routing library. George, are you all set?
I am, and let me go ahead and share the screen. Okay. So my project involves the development of a user configurable client-side routing library. I am planning to do a case study where I develop an historical walking tour using the routing library. My name is George Adams, and my advisor is Dr. Jan Oliver Walgren. My background is in software development and industrial engineering, so I was interested in doing a capstone project that relates to both fields. I have worked in industry for decades, programming controllers and developing scientific software. I don't have much experience with web app development, so the work in this project will allow me to learn something new. On the right, I'm showing a tour guide of historical properties in Castroville, Texas. And throughout the presentation, I refer to Castroville. Castroville is a small town, population about 3,000, located about 30 miles west of San Antonio. And as you can see, Castroville has several historical properties located in a central area of the city. These are mostly houses from the 1800s, built by Alsatian settlers. These houses are usually one-story structures with a salt box style roof, which has one long sloping side, as shown in the photograph. And the Castroville tour guide provides a static, predefined tour. In this project, I intend to develop a dynamic web app walking tour of Castroville historical properties. The purpose of this project is to develop a user configurable routing library and demonstrate its functionality in a historical tourist web app. The library will be free and open source. It will be a client-side JavaScript library as opposed to a server-side solution. It will generate optimal routes through a set of points of interest based on user-supplied filters and constraints. In my case, the points of interest are historical properties. And my intent is to provide an affordable, easy to implement solution for local governments and small nonprofits. Note that routing and path generation algorithms can be complex. My intent is to efficiently implement the algorithms and build a useful client-side routing solution. In reviewing existing tourist apps, I noticed they typically have static routes as shown on the story map to the right. In addition to not being able to configure routes, the tourist cannot filter points of interest or POIs. The story map tour that I am showing to the right is a quick and efficient way to develop tours through an historic district, and there are several examples online. However, this Esri solution can be costly with the GIS professional subscription at about $700 per year. And I want something better. I want an affordable, easy to implement solution where the tourist configures their routes and selects POIs to meet their interests and needs. I also looked into personalized routing apps during my literature review, and personalized routing apps generate routes based on the user's context and environment. So for example, a less experienced driver may want a route where travel can be easier, possibly using roadways with less traffic or where historically fewer traffic accidents occurred. Alternatively, crime may be a concern, and a driver may want to travel through lower crime areas of a city. As shown on the right, a driver could choose the shortest route on the left image, or drive a route along street segments having the best total safety score as shown in the middle image, or drive a route that not only looks at overall safety of street segments, but also identifies crime hotspots as obstacles to travel. And I'm showing this on the far right image. My takeaway from the literature review is that someone should be able to personalize their route by setting configuration parameters and selecting POIs that interest them. This work is important for some other reasons as well. There are some free and open source software server-side solutions, and I experimented with one of them during the development of this proposal. When using a server-side solution, ultimately you will need to implement a routing server of your own, and this can be expensive for local governments and small nonprofits. The challenge here is to efficiently implement a client-side solution to the traveling salesman problem. The traveling salesman problem is typically phrased as follows. Given a set of cities and distances between each pair of cities, how do you find the shortest route that passes through each city once and returns to the starting city? In my case, I will be trying to find the shortest route through historical properties on a walking tour. This is what I call the routing problem, and its complexity is n factorial. A brute force solution looks at all paths and picks the best one. To illustrate the complexity, consider the case of 10 nodes. And 10 nodes would be like 10 historical properties. In my case, each node, the goal is to find the shortest distance past all the historical properties. For 10 nodes, there are more than 180,000 possible paths. Add one more node and there are 1.8 million possible paths. In this presentation, I'm going to discuss routing algorithms and path generation algorithms that can be used to find a good approximate solution instead of using a brute force approach. There are two ways of looking at the work in this project. One is from the tourist perspective, and the second is from the perspective of the web app developer. The tourist sees the properties on a walking tour and the web app user interface. The web app developer sees the routing library and its associated input data sets and integrates them into a web app. I want to bring these perspectives together in this presentation. I intend to implement a case study for the routing library where I use it to develop an historical walking tour in Castroville, Texas. This slide shows my intended web app user interface. I want a tourist to easily navigate the historical properties and configure a route that suits them. So as shown by the call out labeled 1 on the tour button, a tourist should be able to open a screen and build a tour. In doing so, they can constrain the tour to more accessible street segments and limit the length of the tour. For example, someone may need a short tour because they only have a lunch break available. Also, a tourist should be able to filter points of interest to suit them. The web app developer will rely heavily on the routing library. The library will generate an optimal or minimum cost route among a set of points of interest or POIs. The route generation algorithm will solve the traveling salesman problem. Within this algorithm is a cost function, and the goal of the routing algorithm is to find a route through all the POIs to minimize the cost. The cost function could incorporate different factors such as distance and time, or even safety and ease of travel as described in the personalized routing apps previously. In my case, the cost will be distance, and I will find a route that minimizes the distance through all POIs. I intend to use the simulated annealing algorithm to solve the traveling salesman problem. The image on the right is an animation developed by Mr. John Walker at 4 Mile Lab in Switzerland. It shows the simulated annealing algorithm executing on 50 points located randomly in the gray rectangle. It is based on straight line distances between points. My case will be a little different. Instead of straight line distances, I will consider paths along a street network. I'm going to go ahead and show this algorithm executing now. This algorithm has its analogy in the field of metallurgy, where metals are heated and then slow cooled to relieve stresses. Similarly, this algorithm starts at a high pseudo temperature. An initial route is identified at random, then a series of processes are applied to that route while lowering the temperature. If a transport process is applied, then a section of the route is selected at random and moved to another location. Alternatively, if a reversal process is applied, then a section of the route is selected at random and the points within that section are reversed. Afterwards, the transform route is evaluated to determine if it shows a shorter total distance. If so, that new route is kept. If not, the new route may or may not be kept depending on the temperature. As the temperature drops, fewer, less optimal routes are accepted. And the goal of this algorithm is to find a global minimum without getting stuck in a local minimum. And I think you could see that it executed maybe around 35 seconds and it had 50 points, which is pretty good. So what are the key elements to route generation? The input to the routing algorithm is a distance matrix. Each cell contains the distance between each pair of points of interest, or POIs. As shown here, POIs 1 and 2 are separated by a distance of 1.3 kilometers. This matrix is symmetric about its diagonal, indicating that the direction of travel is not unique. However, the distance matrix for the routing library will contain something more in each cell. Each cell will contain a path object. I am showing a path object in GeoJSON format here. GeoJSON is a standard data format, and I intend to specify features such as points of interest, paths, and the street network using GeoJSON. A path object contains a distance, and I circle this property in the GeoJSON code here. However, the importance to using a path object is that it specifies a geometry as well. The geometry defines the sequence of coordinates for traversing street segments from one POI to another. A path object may have additional properties from what I am showing, and the web app developer can tailor the path object to their own application. At a minimum, it needs to have a distance and geometry for the routing library. Note that a path is more than just a straight line distance that is shown frequently when illustrating the traveling salesman problem, and what I'm showing in the bottom right figure. The path follows a street network. Therefore, the optimal route is dependent on the street network as shown in the upper right portion of the slide. One more thing, it is important to also limit the length of the optimal route. However, in doing so, some points of interest may need to be skipped. I intend to implement a simple algorithm to limit the length of the optimal route. I will look at POIs that are furthest in terms of straight line distance from the tourist's current or starting position and eliminate them until the optimal route falls within the tourist length constraint. Then the optimal route may change to the image shown in the upper right corner of the slide. Because the route generation algorithm is dependent on a distance matrix of path objects, it is important to see how the paths themselves are developed. To generate the distance matrix, I intend to implement a preprocessor. And excuse me. The preprocessor will generate distance matrices once, and then the routing library will use these distance matrices over and over. I plan to develop the preprocessor using Python scripts. I see JavaScript as a good tool for web app development, and Python is a good tool for developing standalone applications. At this point, I know the functionality of the preprocessor, but I don't know if I want to make it a more extensive standalone application. For example, I have used Python to interface to Microsoft Access databases. Maybe I would see some value in doing this, or maybe I would want to take advantage of other capabilities in Python. So at this point, I am planning to develop the routing library using JavaScript and the preprocessor using Python. There are two inputs to the preprocessor. And the first one is the set of POIs. I plan to retrieve historical properties from the Castroville hard copy tour guide and create a point shapefile using QGIS. I will convert the shapefile to GeoJSON format for my application. I may also supplement the Castroville tour guide using information from the Texas Historical Commission. I found during a recent walking tour that not all historical properties are shown in the guide. The second input is the street network, and I intend to obtain the street network from Harvard Dataverse. The data set includes nodes and edges shapefiles for cities throughout the country, but one set includes shapefiles for Castroville, and I will import the shapefiles into QGIS. I will add fields important to my application and export the resulting shapefiles as GeoJSON files. Someone using this data set would not need to add fields. They could export it to GeoJSON format and use it directly with the routing library. This slide summarizes my data sources, input to the preprocessor, and distance matrix output. I have described my inputs in terms of my case study for an historical walking tour. Other web app developers would follow a similar approach for their own application. For example, a public works director could use the routing library to survey field equipment and supply equipment locations as POIs. Also, someone could use the routing library for a customized tour through a park and supply their own trail network instead of a street network. My intent is to implement the A-star algorithm in the preprocessor, but I also want to explore some alternatives. The A-star algorithm finds the shortest path between a pair of POIs. So to generate a 6x6 distance matrix, I will need to run the A-star algorithm 15 times, as shown in the shaded portion of the distance matrix on the right. In my application, the distance matrix is symmetric, as the direction of travel is not unique among each pair of POIs. Also, the A-star algorithm includes a heuristic that is used to focus the solution in the direction of the target POI. But without a heuristic, the A-star algorithm becomes the Dijkstra algorithm. Dijkstra's algorithm finds the shortest path from one node to all other nodes in the street network. The Castroville street network has 256 nodes, so this algorithm would start from one POI and generate a shortest path to the remaining 255 nodes in the network. There may, however, be ways to make this algorithm run more efficiently. And the last algorithm is the all pairs shortest path, or Floyd-Warshall algorithm. And this one finds the shortest path from all nodes to all other nodes in the network. For Castroville, it would generate a 256 by 256 matrix. Like Dijkstra's algorithm, I may be able to find ways to make this algorithm run more efficiently. When generating a distance matrix, the shortest path needs to be found between each pair of POIs. So multiple possibilities exist, for example, between the green markers. So you may have a path that looks like this, or this, or this. I am making a simplifying assumption in this project that paths are generated from the street node nearest a POI. A POI usually sits between two street nodes, but accounting for this offset can complicate the calculations. In future work, I want to generate paths from the actual POI location, and this is something I can explore in future development efforts. There's one other thing to consider when generating paths. I want to generate routes that are accessible to people who may have difficulty walking. And so to do this, a tourist could place an accessibility constraint on roadway segments and prevent some routes from being generated. In summary, the preprocessor generates a distance matrix of path objects. It takes points of interest and a street network as input. The distance matrix component of the routing library retrieves pre-generated distance matrices, and the route generation component generates an optimal route through user-filtered POIs that adhere to user-specified constraints on the road network. In this project, I want to explore the possibility of moving the preprocessor code to the distance matrix component of the routing library so that distance matrices can be generated on the fly. And the advantage to generating distance matrices on the fly is that real-time updates to POIs or the street network can be reflected in routes that are generated. My distribution will be through GitHub. I plan to use the MIT license. It allows me to copyright the software and make it freely available for commercial and non-commercial use. It also provides an indemnity clause protecting me from liability for the software's use. I plan to develop both the JavaScript and Python software using the Visual Studio Code development environment and manage revisions to the software using the Git configuration management system. Faraday provides a tutorial in using Visual Studio Code with the Git configuration management system, and a GitHub repository. I set up the environment already following this tutorial. I plan to initially deploy the web app using my Penn State Pass account that we have used in our classes. I would like to move the web app to another hosting service such as Amazon Lightsail when I complete the project. Amazon Lightsail would cost about $60 per year, and domain name registration renewal is another $12 per year. There are several possible presentation forums that I'm considering. However, my preference is the Pennsylvania GIS conference in June. I intend to discuss various applications of the routing library. In addition to using it in a tourist web app, I think it could be used by public works departments. There's also the Washington State GIS conference and the GIS Pro conference, and these conferences are frequently attended by ERISA members. I think the routing library would be interesting to this audience. I'm also interested in the Industrial Engineering Conference because my background is in industrial engineering. The due dates are too soon this year for completing this work, presenting at the conference, but I hope to present there sometime in the future. The purpose of this project is to develop a user configurable, free and open source software, or FOSS, client-side routing library, and demonstrate its functionality in a historical tourist web app. So at the end of this project, I expect to have this client-side routing library available to the public and deployed on GitHub. I would also like to see if the results I generate are comparable to results from other routing engines. An open route service is easy to use, and it is easy to build routes from its API. So I would like to implement test cases where I compare my routing library output to optimal routes generated through the Open Route Service API using various sets of input POIs. Second, I would like to have a publicly available tourist web app that demonstrates the functionality from the routing library. I want this web app to allow the tourists to select POIs and constrain the routes generated to meet their interests and needs. Third, I want to develop some ideas for future work. I think there will be room to upgrade the algorithm I develop or include different algorithms. I may also identify areas where additional functionality is needed in the routing library. And last, I want to present at a GIS conference. My hope is that others will see this solution as affordable and easy to implement for their own applications. The house on the right is one that I ran across by accident. And sometimes as I drive through Medina County, Texas, and Castroville is within Medina County, I find what appears to me to be historical homes from the Alsatian settlers. This one is in need of repair, but it could be included as part of a historical tour web app, which would help the community identify properties that need to be preserved. Excuse me. My timeline centers around completing the project this fall and spring. An abstract for the Pennsylvania GIS conference is due at the end of January. My plan is to set up the input data set first and build the preprocessor. Then I plan to develop much of the routing library and demo tourist web app in parallel, with my focus early on the routing library. I want to make good progress on the routing library before the abstract is due at the end of January. I've also allowed some time at the end to explore alternatives. There are 3 potential path generation algorithms. Also, the A-star algorithm uses a heuristic. I'm going to use a simple straight line distance for the heuristic, but maybe there are better choices. I could even look at other possibilities for the route generation algorithm. Instead of simulated annealing, I could look at the genetic algorithm. I also want to look at the possibility of eliminating the preprocessor and moving path generation to the routing library. I don't know now if this would be beneficial or practical, but it would be good to understand this option better. And any questions?
Okay, thank you, George. That was quite impressive. Any questions for George?
And one thing that I'd point out for Castroville is that it's a population of about 3,000, and what's just shown up in the paper just recently is a new housing division is being built on the outside of town on just over 400 acres, and it's going to be 950 houses. So it'll essentially double the size of the city. So, and I see I have a question from Fritz Kessler. A very interesting algorithm to planning the routing. Have you considered any kind of ongoing user testing to see how well the system works during the development phase? I think I'll plan to use it in Castroville and test it myself. I'm actually a member of the Castro Colonies Heritage Association. So this is one of, there's more than one historical group in Castroville. So the city actually has a historical board. There's this historical association, and these are basically descendants of the Alsatian settlers. And then, they just formed another group to buy some of the historical properties downtown so that the new development doesn't kind of take over some of the historical properties. I'll test it myself. I don't know that I'm going to have other people test it. I may actually, go into the Castro Colonies Heritage Association with the app and see if people are interested, and if they are, provide it to them and let them work with it and provide me feedback, and we'll see how that works.
I had a question. It seems to me that perhaps not for the Castroville case that you're going to be using it first, but it seems to me in other situations it might be important to have data on sidewalks. And I was wondering if that was something that was included in that Harvard data that you plan to use.
No, it's based on OpenStreetMap data, and for Castroville, there really isn't coding of sidewalks, and that was one of the concerns that I have, because I wanted to be accessible. I actually wanted an application where I'd have some constraint on the road network, and originally I was thinking, well, it'd be really nice if it was wheelchair accessible. So are some of these street segments coded wheelchair accessible? And they're not. And if you actually walk in Castroville, it's this little town. Most of the streets don't even have curbs. It's basically the person's yard goes right out to the street. The grass goes right off to the street. There are not many places where there are sidewalks in the town or around these historical properties. Still, I want to add a field that provides some information on accessibility. And so, I'm going to actually walk through some of these areas of the town and try to identify places where I think somebody who has difficulty walking could actually use the Tor app and could actually walk. I don't want it to be necessarily confused with being ADA compliant, where there's actually cutouts at the corners of any of the sidewalks that do exist. And some of them kind of in the center part of this historical district, there's a park. It's called Houston Square, and it's where this very old church is located as well. Some of that area does have sidewalks, but I don't know that much of that is even ADA compliant, even those sidewalks. So, I need to actually walk through and check it. My data set, I'm going to mark segments that I think are accessible for people that could actually walk these routes. So.
Good, thank you, George. Any other questions? I have another one if no one else comes through in the chat. And that is, in web app development, I know there's the concept of if your app takes too long to load, you're going to lose your viewer, your users. Do you have any sort of target in mind with regards to that? I know that you're doing pre-processing, which should help tremendously. But have you thought at all about that?
Yeah, that was kind of that on that demo that I was showing. Those were 50 points, and I think it was like 35 seconds, somewhere in that ballpark is where it basically produced the route, and that's where the delay is going to be. It's going to be in generating the route, I would think. I'm actually going to be looking at 10 to 15 properties for this, for at least my development effort here, and so my hope is it would execute pretty in a fairly short time, but it's still going to be a noticeable delay. And
Mhm.
so, I'm going to have to actually produce something to the screen that lets the user know that, it's not just dead, it's doing something, but yeah, that is a concern of mine. The speed with which it can, it can actually produce a route, and people not being discouraged if it's if it does take some time to generate the route through these various points. But my hope is that I don't really plan to go much beyond that, the 50 points in the end. And but you can kind of see what the simulated annealing algorithm seems to be able to accomplish within this app. So
Mhm.
that is a concern that I have, but I'm hoping that it turns out to be very good, because this will be a free software. In the past, I've actually used like Google Maps to develop applications, a web app application. I did it for a government agency, and one of the concerns that they had was that that I was using a proprietary software, and so
Okay.
I ended up having to rewrite the entire software, and I used a NASA Whirlwind, which was which was acceptable to them, I guess,
Right.
And so
Right.
I kind of remembering that experience, I was thinking, this would be really nice to just, have something that's free and open source. It's available to anyone to use, and my hope is it would be very simple for someone to use, there could be drawbacks. It could be, it could be 15 seconds to load a route or something, but I'm hoping that there would be advantages in that people would see from this. Yeah, and Dr. Walgren said, and it will not be during initial loading, but when the user clicks a button to create the route, right? And yeah, and that's the case. So the delay that you're going to see is it's not. Yeah, I'm not as worried about the initial loading, because I think that would probably be fairly quick. The concern that I would have would be when a route is being generated. So when the user wants to build their route, that it may take 15 seconds or something like that to generate the route. So they're going to have to see something on the screen that tells them that it is actually calculating the route, that the app isn't dead. Yeah.
Okay. Well, thanks very much, George. I really look forward to seeing how this project unfolds and seeing it finished.
All right. Well, thank you.
All right, that brings us to our third presenter, Bridget Burgos, who's going to talk to us about the determinants of crime in Philadelphia. Are you all set to go, Bridget?
Yeah. Hello. Let me share my screen. Okay. Can everyone see my screen?
Yeah, looks good.
Okay. Okay. So hello, everyone. Welcome to my 596A presentation, Testing Determinants of Crime in Philadelphia, a statistical spatial analysis using multi-scale geographic weighted regression. I'm Bridget again, and I would like to give a shout out to my advisor, Stephen Matthews, if he's on. Thanks for helping me put this together. So this is just a rough overview of my presentation. I'll start with scope, then background, literature, goals, data, methodology, anticipated results, challenges, and then the timeline. So essentially the goal of my project is to test the effects of social and ecological factors, or determinants, of crime in Philadelphia using spatial statistical analysis, and see how and if these relationships vary throughout the city. My personal interest with this subject began in my Geography 586 class, when I did my final project on using geographic weighted regression to see if trash had an impact on crime. I didn't really draw super solid conclusions from that project, so I decided to use my capstone as an opportunity to dig deeper on the subject. So dig deeper, I did. Many of the determinants that I'll be testing stem from this concept called the broken windows theory. The theory suggests that disorder causes community fear and disengagement, thus creating an opportune environment for criminals. So this picture is like illustrating broken windows theory. I believe it is like a literal broken window. And basically it's supposed to represent disorder. So if disorder is present in a community, it can lead to that fear and disengagement, and ultimately people assume no one cares about that area, so they can do whatever. In this example, the broken window itself is the disorder. However, disorder can be defined in many ways. Classifying disorder can be tricky because often studies will choose different ways disorder manifests, or even come up with sub-theories about different types of disorder. For my project, however, the types of disorders I've decided to focus on are physical disorder, social disorder, and collective efficacy. Examples of physical disorder are stuff like trash and vacant property. Social disorder includes stuff like economic status, age, and education. Collective efficacy theory basically describes how lack of community and social cohesion can lead to more crime. This can be measured in number of renters or number of people moving in and out of a neighborhood. So the way these qualities can come to define a neighborhood, I thought was kind of illustrated well in this like picture when you have like a contrast of like a fancy apartment complex with like a poor looking neighborhood. And it also just kind of reconnects back to the main idea of like the broken windows theory and how it influences perception of crime and whether it's actually there or not. So these theories on their own are often not enough to create a complete model that can create account for crime, essentially. Thus, more modern studies have used disorder-derived variables in conjunction with other ecological factors to explain crime. So these ecological factors can be stuff like land use, amount of green space, or neighborhood walkability. So statistical and spatial analysis is important to test these concepts because there is a reason to believe that crime differs in concentration based on circumstances. In 2015, Weisberg wrote a paper called The Law of Crime, Concentration, and the Criminology of Place, where he really emphasizes the need for spatial analysis methods to be incorporated in crime studies. When using like demographics and environmental data to explain patterns of crime, all these like data are inherently spatial. Therefore, it is important to consider this when doing statistical analysis. Geographic weighted regression, or GWR, is one method that has been used to account for the spatial nature of crime data. So with that, I would also like to mention multi-scale geographic weighted regression, or MGWR, as a potential method to test for crime across space. Though MGWR is a relatively new method that has not been used to test crime yet, it can be applied to do so. So I thought I could use my project as an opportunity to explore its application. So with all that stuff in mind, my more specific goals are to use regression-based statistical analysis to create a more complete model that incorporates concepts from the broken windows theory and ecological factors that explain variation in crime. I made this flow chart to kind of illustrate what that means. So basically, I'm hoping that kind of all of these variables, if they have a strong positive relationship with crime, then the model will be able to accurately predict crime counts. Then my second goal is to see how these relationships vary throughout the city using MGWR. So the first thing I need to run regression analysis is a dependent variable. And since I'm talking about crime, I decided to use the number of nonviolent crimes to measure this. Crimes are available as points in shapefiles for most years. The files from 2015 to 2019 were downloaded from the city's open data portal. Shapefiles for each year contain part 1 and part 2 crimes. Part 2 crimes are the ones that are considered nonviolent offenses. The crime data are logged as incidents based off of preliminary police reporting. So that means that they can be like subject to change at any time. The unit of analysis that I'll be using is US Census block groups that make up Philadelphia. And this was available as a shapefile from the US Census Data Explorer. So total nonviolent crimes from each year were aggregated into block groups, then averaged to capture one representative crime count. So my dependent variable is an annual average number of crimes per block group. So this map I made here kind of shows like the initial distribution of average crime counts. So I can already see like places where maybe it's relatively high or low. And also if anybody was wondering why I picked Philadelphia, it's because I live right here. So now that I have my dependent variable and units of analysis, I was able to start collecting my independent variables. I've categorized my variables based on which theory they fall under. So for social disorder, I've chosen all these like socioeconomic variables to include. However, just for this category specifically, I'm approaching it in like a slightly different way. Basically in 1997, a guy named Sampson found that all these factors contribute to like overall population health and like mental well-being and like, you know, crime. So the concentrated disadvantage index was created to better capture all these attributes to use in one model while reducing the possibility of redundancy. Collective efficacy or community cohesion will be measured by total population that lived in a different house 1 year ago and total population that are renters. To capture physical disorder, I'll be using total square footage of vacant property and the Philadelphia Litter Index, which is a pretty cool data set actually, because it basically rates all streets on a scale of like 1 to 5 based on how much litter there is. And pretty much like no other city has like a data set like this. And in many crime studies that use trash, they either measure that through survey methods or researchers have to collect the data themselves. Other ecological variables that I'll include are the EPA's walkability index that rates block groups on how walkable they are and general total population. So these are all like my ecological variables for now. I may decide to include more or different ones later, just depending on the strength of my model. So in order to do statistical analysis, I have to aggregate my data to the same level. So all the tables that contained population attributes will basically be like sorted and calculated in Excel and then joined via block group ID later in ArcGIS Pro. Other variables such as litter and vacant property must be aggregated within ArcGIS Pro by block group. So basically after I have all my like variables wrangled, I'm going to have all these attributes per block group in one table. So this is just an overview of what my process will be. So to recap, I will be using regression to see if determinants have a positive relationship with crime. The main methods I will use to do this is essentially linear regression and MGWR. I'll be running my general regression in ArcGIS Pro, then running the MGWR in a program that was developed by the University of Arizona called the MGWR program. Since the program doesn't have a mapping interface, I will have to map the results back in ArcPro. So the specifics of my statistical analysis are kind of illustrated like in this flow chart. So basically it describes kind of the steps for regression for a spatial data set. First, I need to perform linear regression. Then I can move on to the multi-scale geographic weighted regression. Then just depending on my results, it may or may not be the most suitable model for the data. So to start with the global linear regression model, It's basically described by this equation, and the important things I guess I wanted to point out about this equation are that it's basically calculating like a predicted variable based on observed values and explanatory variables. So it'll be like calculating like predicted outcome crime based on like the actual value. So after running the generalized linear regression tool in Pro, the results that I'll be most interested in are the R-square value, coefficients, and residuals. The R-square value indicates how much the variation in crime counts are explained by the determinants. The coefficients are how much strength each determinant has in the model, and the residuals will indicate how far the predicted values are from the actual observations. So that should give me a pretty good idea of what the general relationships will be, kind of. So the linear model assumes that all processes are stationary and independent of each other. But I know this isn't true because even just from running a hotspot map of the crime counts, it's evident that low counts tend to gather around low counts and high ones around high ones. But just to confirm this for the results of the linear regression, I'll be making a map of the standardized residuals to see if there is clustering. I will also run a Moran's eye test on the residuals to test for spatial autocorrelation. If spatial autocorrelation is present among the residuals, this violates the independent and identically distributed assumption of an OLS model, and thus there'll be a need for spatial modeling, which is where geographic weighted regression comes in. To define GWR loosely, it basically takes that equation that was used in the OLS and runs it at every data point and uses the value from close by neighborhoods to calculate the predicted value at every point to kind of create local regressions. The bandwidth is the distance band that determines number of neighbors used for each local regression. So this diagram is illustrating how bandwidth kind of dictates the circumference at which these neighboring data points will get absorbed and influence the predicted value at this point right here. So this is important, so just keep it in mind for a second. But the results of the general GWR is, the most important ones are a localized R-squared and localized coefficients. So in this map here of property crime in Toronto, in the Toronto area, basically their model fits pretty well in like this area, but not so well in this area, just according to their R-square. So many studies that have used GWR often use it as their primary method of spatial analysis. But there was a recent paper that's still under review that suggests that actually using MGWR would probably be a better method of just like starting this analysis. And it's because of that bandwidth that I had mentioned before. In a GWR model, bandwidth is optimized based on averages for all variables and is constant across all data points. MGWR uses different bandwidths which can distinguish which variables affect crime on a global scale compared to variables that have impact on a local scale. So to put this into context, say if my walkability variable has an overall global impact on crime values, this will cause the average distance bandwidth to be larger in the GWR model and basically have an influence on like all of these points. But if my renters variable doesn't have the same global impact, but say has like a smaller one, this relationship would not be reflected in the GWR output. That's why MGWR could better decipher this relationship because it's using the different bandwidths. So once the MGWR is done, I can compare the results of the linear regression to see if the spatial autocorrelation is resolved. If spatial autocorrelation is resolved and MGWR produces multiple bandwidths, then it's likely to be the best model. Basically in this example, just of what I put in the MGWR model so far. I put in my crime counts and tested them against some of these variables. And already there are multiple bandwidths that are being used. So if these bandwidths were all similar to each other, then a GWR model would potentially be the better model. I believe the results from the linear model and spatial model will support a positive relationship between determinants and crime. And I also believe that the MGWR will better describe these relationships across space or the city of Philadelphia. So these maps here are from a study that tested correlates of obesity rates in, I think, Tucson, Arizona, using MGWR. And this is basically the output results that are mapped. And these maps are describing the relationship of the obesity rates between Hispanic and Black populations. And basically the places of color are where these determinants have the most statistically significant relationship with obesity. So like this one's like positive and this one's negative. But basically I expect to see similar patterns with my determinants across Philadelphia, but maybe not necessarily for all of them. Maybe just like some will have localized ones and some will affect it on a wider scale. So for challenges, one of the ones I will be dealing with are my selection of variables. The ones I have chosen may still not be enough to make a strong model to predict crime counts, or they just might not be enough, or I've chosen the wrong ones. But also I will likely probably have to further separate crime types. Since for now I'm just testing all nonviolent crime. This can include crimes that have no geographic significance, such as fraud or car crashes. So if I suspect that if I further separate crime types, it would strengthen the model. There are also several assumptions about the OLS linear model that need to be addressed. This includes things like data distribution, nonlinear relationships, or high zero counts. The data can be manipulated to fit the linear model. However, a lot of researchers would argue that I should probably just be using a different type of regression, but I only choose to stick to the linear model because it is the more heavily researched one for GWR and MGWR. So I am expecting to present at the American Association of Geographers Conference at the end of February. I submitted my abstract just on October 19th. So then through November to December, I'll be aggregating my data and doing my tests. And then December to January, be mapping and interpreting results. And then that'll give me February to finalize my paper and presentation. And those are my references. I have a lot, and that's it. If anyone has questions.
All right, thank you, Bridget. That was a nice presentation. Do we have any questions for her?
I have a question. So you're looking at 2015 to 2019, right?
Yeah.
As your, okay. So did you consider kind of comparing, I know it would change your scope completely, but did you look into like comparing after 2019 once the effects of COVID kicked in, you know, the effects on the economy and everything else?
Yeah, I mean, that would definitely be like a really cool way to approach it. The only reason that I'm looking at before 2020 is just kind of like I basically found all of my data variables first, and then everything else after that was kind of making sure all the timelines fit. So a lot of this data is like not available for 2020. So that's why I was looking at 2015 to 2019.
That's fair enough. Well, and once you kind of get your analysis down, would you have any interest in going back and kind of running the new data through in a couple of years, maybe?
Yeah, for sure. Definitely to compare. But it's also hard because some of these factors that I'm looking at may have just like a completely different impact when considering like the effects of COVID-19, you know, because that was such like a dramatic event, and, you know, it influenced like crime rates all across the country and stuff. So I don't know if my exact like approach would apply to like later data, you know.
Yep, I appreciate it. Thank you.
Katie, this is George Adams. I liked your presentation. One of the things that I did in one of my classes was also a crime study on the town where I live, but the town where I live has a population of like 10,000. And so I guess even though I was able to collect data from the county, you know, they were willing to give it to me. It just seemed like overall I just didn't have enough data, you know, to do it. But it doesn't look like that problem exists for you. The one thing that kind of comes to mind for me, though, what's happened in the last several years has been there's been a lot of more focus on police enforcement, and you know there's been a lot of things like, you know, people have thought about this idea of defunding the police. I think Austin has had this show up in the newspaper. Do you think that just the change? Well, I guess you're not even looking maybe during that period of time when some of these police practices seem to have been changed. I mean, will that affect what you're doing at all, or is it just not within the timeline, I guess is kind of what I was thinking.
So some of like the background and literature that I combed through definitely does apply to policing methods. Definitely like broken windows kind of shaped some of the like policing methods that exist today and that have like kind of proven to be problematic because it leads to stuff like racial profiling. But I think for the scope of what I was looking at is not so much to kind of prove whether like certain places should be policed or not, but kind of more of just how population and like physical attributes on their own can like play an influence on crime rates, if you get what I mean.
All right, thank you. I know that when I had done my work, I'd sent my stuff off to the police chief. I never got a response from him, but do you think you might send it to the city or send it to somebody there?
Maybe. I think it just depends on my findings, honestly. You know.
Yeah, that was my question as well, as whether you saw or had any thoughts about this translating into public policy in any way.
Yeah, definitely like public policy. So like one interesting thought I had, because my original idea had to do with like that trash and litter data, is, you know, if there is a correlation between, or well, you know, like a relationship between, say, one type of crime and like trash, if that's really strong, then I wonder if it would be worth further researching and maybe seeing how street sweeping, like implementing street sweeping in those areas, if that would like later on change crime counts. You know, it's a stretch, but it is like kind of something that I thought about that could at least like help maybe like shape future research with that, you know.
Yeah, absolutely. Any other questions for Bridget? Okay, well, thank you, Bridget, again.
Yeah.
Nicely done.
Thank you.
Next up is, 1 second here, is Ty Manning, who's going to be talking to us about GIS development strategies for local government. Ty, are you all set?
Yes, I am.
All right.
Okay, so I guess I'll get started here then. Let me just share my screen. Okay, can you see that?
Yes, I can. Looks great.
Sounds good. Okay, so hello everyone. My name is Ty Manning, and my capstone, I chose to cover GIS development strategies for local government, and this entails the creation of guidelines for that local governments can follow to understand, develop, and implement a successful GIS. So before I get going, I just want to cover kind of some of the topics that I'll be showing within this presentation. Okay. So just a quick little overview, kind of highlighting the major points of my capstone project. What I want to cover is today there's many local governments, especially in rural areas, including towns, villages, and up to the county level that lack the appropriate geospatial management skills and resources to kind of organize their spatial data within their organization. And this capstone is intended to develop a guide or a framework that these governments can follow to assess their needs for GIS and to design a working GIS within their organization. And a key aspect to consider when designing this guide is to make it scalable so that it can work from a small village level to a larger county level. And as part of this this project, I plan on working with Southern Tier Central Regional Planning and Development Board, also known as STC, and Schuyler County to test pilot this guideline. And I'll kind of work simultaneously with the development of this guide and then working with this county to kind of implement it. And for the deliverables, I'll be developing a web page that hosts this guide and then present my findings at a conference. So a little bit of background, the importance of GIS for local government. Today, with increasingly growing need for technology, especially in government, and the need for accurate and easy to access spatial data, GIS is becoming a crucial aspect for all governments to possess. People nowadays expect to have accurate data at their fingertips through mobile devices or web applications, or just going online to be able to access information. And the problem is that many, especially in rural areas, many mid to small sized local governments don't have access to a working GIS due to lack of resources, such as staff or technology or software, or just lack of knowledge that they might not know the ins and outs of GIS or how it might benefit them. And this results in outdated, unorganized, and inefficient spatial data management practices. So integrating GIS into municipalities offers a number of benefits ranging from improved workflows to higher quality management decisions and even financial savings. And this is something that I'll try to convey in this project. So going to the case study that I'll be working on, Schuyler County is a pretty rural county located in the Finger Lakes region of New York State. As you can see in the map there, it's the population is, as of 2019, is about 17,800 people. and their major source of income is based off the tourism, especially in the summer months. Within the village of Watkins Glen, they have Watkins Glen State Park, which people come from all over the region and even the world to see the waterfalls and walk the Glen. It's a pretty nice spot. And then short drive from that is Seneca Lake, which is one of the Finger Lakes, and it has dozens of wineries and breweries surrounding it. So great spot to visit. And then they also have Watkins Glen International racetrack, which NASCAR has a race there once a year, and they have other festivals and whatnot. And within the county, there are 8 different towns and 4 different villages. Many of these are pretty rural and each differ in the resources and technology that they have there. So some of the geospatial issues that are faced by municipalities today. So from experience, I was able to work with a smaller scale engineering firm in upstate New York. And I worked alongside many different municipalities and helped them with some of their mapping requests, especially the smaller scale and more rural municipalities that didn't have any GIS access really. So they would have to kind of ask for help from firms. And this is an example of one of the maps I created for the highway department for the town of Big Flats in Chemung County. And this town was pretty interested in GIS and having and utilizing it, but they still had to kind of source that out because they didn't have the internal staffing or resources to produce their own maps. And these small scale municipalities, they many times rely on outdated methods of mapping, such as hard copy, pen and paper maps that they just kind of sketch out, referenced old engineering drawings that might be many years old, scattered shape files or other types of geospatial files. And then in some cases, there's no documentation of their spatial assets at all. So as a result of this, these municipalities will many times need to contract out to firms like the one I used to work for. And a downside of this is that they might be able to request that that mapping to be done, but they don't have immediate access to it. It's still kind of in the hands of the firm that they reached out to. So it would be beneficial for these municipalities to kind of understand how to have access to that, and even if it's just viewing access to implement GIS would benefit that. And then another issue is that in many cases for these rural and smaller communities, they have minimal funding for these types of technology projects. So in many cases, they'll have to rely on grants, which there's plenty of grants out there. So this capstone project will kind of focus on highlighting some of those potential grants and opportunities. And then finally, the minimal staffing and technological resources that these municipalities have, this is a big issue faced by a lot of them. So back to Schuyler County, the current mapping landscape within the county that they have right now, they only have one employee that uses GIS on a semi-regular basis, and this is their planner, who I've actually been kind of working with getting this project started and just learning more about the county and what their needs are, who their potential users and applications might be. And right now the county has only 2 ArcGIS Pro licenses and 2 viewer licenses. And many of the towns and villages within the county rely on hard copy paper maps to track their spatial assets. Example of some of the mapping that happens within these towns and villages. One of the towns only has one paper map left, and it's kind of on its last leg. So once this goes, they're kind of left with nothing. Another village has some of their, I think it was like their sewer infrastructure drawn, just sketched out on a whiteboard, which can obviously be deleted pretty easily. So they could definitely benefit from a working GIS to kind of store their spatial data in a safe, well-organized method. The county does have a website that hosts some of their, you can see right here, these are the maps that they have available, and they're pretty simple. They don't have much, but that's why this case study might be good. So some of the literature that I've found related to this project ranges from state-produced GIS implementation guides for local government to county-based needs assessment reports for GIS development. And those have been some great resources that I've found. Esri also has a few white papers and web pages and other useful information that addresses local government GIS. Each of these cover the fundamentals for properly planning, designing, and implementing a working GIS. Although a downside to some of these, or most of them that I found, is that they're really kind of outdated. So you can see here, like, this is a great source for a guide for municipalities, but it was produced in 2002, and this one also 2008 it was produced. And a lot has changed since then, from web mapping in the cloud and all that. So that's something that I'll touch on too in my capstone. So just a little bit more covering some of the literature that I found. A great piece of literature that I'll kind of reference quite a bit is the state of Massachusetts developed an 88-page guide that is intended to improve this geospatial presence within the state for their municipalities, towns, villages, and counties. As you can see here, some of the major topics that are included within this report. Kind of covers just from scratch how a government can implement the GIS, what they need to look out for, understanding the needs of it, the users, software, hardware, et cetera. So this is something I'll be able to reference. Also, a county, actually neighboring Schuyler County, who I'll be doing the test pilot for, Steuben County hired Fountain Spatial to create a GIS needs assessment report, which also includes conceptual system design and an implementation plan to kind of go over before they implemented a GIS within their county. They hired out this company to do an in-depth study, and they came up with a report that kind of went through a logical flow and organized way to detect the needs, the users, existing data, existing software, and then to produce a solution that the county could follow to implement GIS. So the goals and objectives of this capstone is to produce a scalable guide that local governments can follow to identify the benefits and applications of GIS, and develop a design strategy to produce a well-organized GIS that fits the needs of their organization. And a quick little storyboard that I came up with that'll just cover there'll be 4 major sections that I'll focus on within this capstone project for the guide. The first section will be the marketing section, and this is where I'll just kind of give an overview of what GIS is, how it can fit into a government or agency, what are the applications that GIS could assist with within a municipality or county. It'll also cover some of the resources out there, some of the training, some of the grants and funding and all that. And it'll also, very importantly for many of these more rural communities, it'll highlight some of the financial aspects of GIS and what costs might be or how it can improve costs in the long term. The next section, this will be one of the bigger sections, is the needs assessment, where I'll produce kind of a framework that will highlight what to look out for when thinking about implementing a GIS and what the municipality needs to think about. And for this, I'll reference some MGIS courses here at Penn State, as well as some of the literature I talked about earlier. And within this, it'll highlight the importance of understanding the roles that GIS will play within the organization, identifying users, resources available, existing infrastructure that the municipality has, and more. The third section will be the design section, and this will also reference some of the MGIS courses here, and then some of the literature that I found. But this section will it'll kind of focus on covering a example GIS architecture that could be implemented. And for this, I'll focus kind of more heavily on ArcGIS Enterprise for a number of reasons. But I'll also cover some of the open sourced options, as well as ArcGIS Desktop. And then the implementation step or section will entail a list of steps that the government that's looking to implement a GIS can kind of go through, and from the start, what they should look out for and how they can actually get the GIS implemented into their organization. And all of these sections right here will end up on the webpage that I mentioned earlier. And it'll be just an easy to navigate, visually pleasing webpage. Back to Schuyler County, what kind of they're looking for and what I'm hoping to accomplish with this test pilot, with assistance from STC, who is the regional planning agency that I'll be working with, Esri, and this capstone project. The county is looking to explore a more organized and effective method of maintaining their spatial data, in which that the county departments and municipalities and even the county residents will benefit from. So a quick little overview of what this might look like when everything's finished is that there'll be an Esri Enterprise Geodatabase, which STC will kind of be the GIS administrator, and it'll be hosted on their server. The reason of this is that there's other surrounding counties that they work with too that might down the road want to also tie into this Enterprise Geodatabase. And Schuyler County will be the data owner. So at the county level, they'll be able to maintain and manipulate and analyze and have access to all their data. And they'll be able to, the departments within the county, as well as the municipalities, will be able to use and view and edit or create new data here. So ultimately, the county will have a centralized GIS database, which they can manipulate and maintain how they wish. And then the municipalities and departments, as I mentioned earlier, that they will be able to view, edit, and create data through use of Esri applications such as ArcGIS Pro Desktop or web maps and web applications like Collector, stuff like that. So continued a little bit more on the capstone, kind of the overview of what it will look like. The marketing section will include some of the outreach to municipalities, established GIS planning committees. This will kind of cover just what GIS can improve within an organization and how it can be kind of shared with how the word of GIS can be spread throughout the organization, and it can bring in like some support, and it can kind of, yeah, I don't know. That'll be the marketing section. The needs assessment section will focus on identifying users, existing software, hardware, existing geospatial data, existing applications, financial status, and even public use. And this will be one of the larger sections. The design section will focus primarily on Esri's ArcGIS Enterprise, as I mentioned earlier, but it'll also cover some free and open source software, and it'll just kind of give an example of what the GIS architecture might look like within a municipality. And then lastly, the implementation section will just be a detailed list of steps to follow in order to get to the final implemented GIS. Here's a quick little time frame of my project. And for the deliverables, so I expect to, at the end, have a working web page that is kind of easy to follow, and it looks nice, and it contains information for this guide that anyone, project managers, government officials, engineers, anyone who is on the team for looking into a GIS can kind of go through and get information about this. This is, I don't know if you can see this or not, but this is an example of Esri's came up with a web page that kind of gives an overview of describing GIS and its applications. And this is kind of what I want to emulate here and create. So this web page that I end up developing will end up on STC's website as a web page there, and as well as on top of that, I would also like to produce maybe a story map to present to Schuyler County, the findings there, and so that they can kind of go through that and understand what has been done and what's been found and how they can move forward. So for the conference, I narrowed it down to 3 options. The first choice would be the Appalachian Regional Commission Annual Conference, which is held in Washington, D.C. From March 13th through 16th. I think this would be a great opportunity to kind of present my findings and to get the word of GIS for government out there. Schuyler County, for the case study, I would ultimately at the end, I'd like to present whatever my findings are for to the county, and this will be maybe through a story map. So this will definitely happen at some point. And then if the first option doesn't go through, then I'll present at STC has an annual conference on March 31st. Held at Corning Community College in Corning, New York. Just a quick recap and summary of my capstone. So I'll develop a scalable guide that GIS local governments can follow to implement a GIS design and put into their organization. I'll work with STC and Schuyler County to test pilot this guide. And then I'll develop a web page that hosts this guide, as well as a story map to present to Schuyler County, and then present my findings at a conference. Any questions?
Thanks, Ty.
Mhm.
Questions for Ty?
Hi, this is Robert Ford. I was just kind of wondering if you had thought about how these smaller entities could potentially bridge data needs with larger entities. I know with my job, a lot of times I'm using federal community stuff that they post on Esri, like the Department of Homeland Security has a huge swath of open data that is very useful for all kinds of things. And I'm just thinking some of these smaller entities may not know that this kind of data exists or how to even go about collecting it if they need it, and that kind of stuff.
Yeah, and I think that's a great thing. That's something I'll definitely highlight in like my marketing section of what's kind of exists out there right now, what open data is available that these municipalities can kind of access and be able to even share some of their data once they start collecting and getting a working database going. Yeah, because I don't think a lot of these smaller governments really know what's out there fully. So that would be great to kind of include.
Hi, this is Mark.
Mark.
One of the things that I'd like to follow on with what Robert said. I work for a state government that is looking to harvest data from the counties, and so that might be another place where you could point these smaller governments to, is that their own states may have resources that they're not aware of or needs that they'd be willing to help with to collect data. The work I do is with roads and highways. We would like to be collecting accurate roadway data from the counties and municipalities so that we don't have to expend duplicate funds to collect that information ourselves. So I don't know if that's incorporated in your work or not, but you might point that out.
Yeah, that's a great, you're saying on the state level, if these communities can kind of work on not only capturing their data, but publish it up so that it's being accounted for in the state data sets.
Right, and it also enforces standards.
Yes.
Across the board, across the state, so that one town is collecting it similarly to another.
Yeah, and that's pretty important. I think that's a great thing to include in there too. Yeah, because right now I know for New York State, they have like the New York State GIS Clearinghouse, which it's got a lot of, it covers a lot of the state, but for some of the data sets, it's missing data from, and that's many times it's rural areas that don't have the greatest GIS set in place, and they're not collecting the data and maintaining it as much. So that would be something definitely to include.
I would have to echo that from the state highway level. We've noticed that.
Yeah. Okay. Yeah. So thanks. Yeah, I appreciate it.
Looks like you have a question from Fritz Kessler in the chat.
Oh, oops. Have you been able to identify specific municipalities for your marketing plan, or what specific criteria you use to select these municipalities? So I haven't yet. I mean, and within the county that I'm going to be working for my case study, many of the municipalities don't have much in terms of GIS. They kind of rely on the county level, who owns the couple licenses. So when I talked with the planner for the county, they would ultimately like to have the county being the kind of the data owner, and then work with each of the each municipality and identify kind of what they would utilize GIS for, and how to kind of, whether it's giving them a viewer license or access to like collector apps so that they could go out and collect their data and maintain it, or upload it into the database, and then have the county level kind of work and analyze and be in charge of that data. I think it'll be on a municipal basis that we determine that.
Ty, you touched on a lack of funding and lack of technical expertise being, big stumbling blocks for local governments to try to implement GIS. So, one of the things that came to my mind was the idea of partnering with local schools, K through 12, and or universities, to, if they have projects that need to be done on a zero budget, that might be something to include in your recommendations.
Yeah, I think that's a great idea, actually. Yeah.
Okay.
And
sorry, go ahead, Ty.
I was going to say, and working with this regional planning agency too. I know that they have a lot of resources too, and working with the surrounding counties, it'll be interesting kind of layout for this design, but it'll be all the counties could kind of benefit from this.
All right.
Here in Baltimore County, our community colleges are also involved in GIS quite a bit. So you might look at that.
Okay.
Right.
Oh, cool. Yeah. I'm actually in Baltimore County, or in the city, but that's good to know. I'll have to look at that.
Tyler, I think this was a great presentation. I think it was a great need too for local governments, because I live in a small town in Texas, and 23 years ago I replatted some property that I owned, and then they published a couple of years ago, they published in the newspaper the planning and zoning map, and I could see that it wasn't recorded correctly on the planning and zoning map. So I guess at the time, 23 years ago, maybe they had a hard copy and somebody penciled it in or something, and it never made it. Never made it 23 years later. That was the first time that I realized that it wasn't platted correctly, because I've been running a commercial property on that property for over 20 years now, thinking that it was commercial. And I find in the newspaper that it's platted residential too. And so I've been talking to the planning, to the city planner I have all the documents, I have the, the signed survey and everything from the mayor at that time. And
wow.
And I have to go back and resurrect all this all over again. So I can really see the value in what you're doing, and it's, to some degree, it's almost like developing some type of an organizational scheme for the county too, how do you organize yourself with the set of data, or what do you do, and kind of like an organized approach to not lose things, it seems like. But the other thing that just in this scenario, what comes to mind is have you thought about like a list of failures that you probably can't publish it on the website, but here's what the kind of like the failure is, and in my case it was not having the planning and zoning map correct, which is going to cost me a lot of time and money. But this is a way to market what you're doing to some of these governments, that you could kind of keep to yourself or something. But what is the cost? Have you thought about that aspect?
Yeah, definitely. And just talking with this county, I mean, that'll be the big kind of that marketing section will be huge, because it'll have to capture the attention of these municipalities and especially the decision makers and county officials, because there are some stories that I heard just from working with the Schuyler County that how outdated and like it's really not an organized approach to dealing with their spatial data, and they're just kind of scrambling to get their data presentable and whatnot. So yeah, I think highlighting some of those instances would be definitely pretty useful.
Okay, well, we're bumping up against the time for the next presenter. So
Okay.
thanks again, Ty. Nice
Yep.
job. And I wish you the best of luck, putting together your site, and I hope it has a good impact.
Thank you. I appreciate it.
Next up is Nathan Mangson, who's going to talk to us about using drones to choose Christmas trees. So I look forward to hearing this.
Well, that's me. Can everybody hear me?
Yep.
All right, great. Let me share my screen and start this. So yes, hi everyone. I'm Nathan Mangson, and this is my capstone project proposal presentation. The title of my project here, as you can see, it's the Furs That Were. It's a drone-based remote sensing applications for choose and cut Christmas tree farms. I'll be doing a changeover time analysis, so they'll be cut down over the Christmas season, which leads into the title. It's meant to explore ways that small Christmas tree farms can benefit from drone-based remote sensing methods and techniques. For me personally, Christmas tree farms have always had a special place in my heart because my great-grandmother lived in a small town in Western Massachusetts, and there was a Christmas tree farm near her house. And at the time when I was in elementary school, I lived in central Massachusetts. And when I was growing up, we would it was a long drive. It was like an hour and a half, but for a kid, that's long drive to visit her, usually about once a month. And passing by that Christmas tree farm was special to me for two reasons. One, it meant that the trip was finally almost over. But more importantly, I was a kid, and just seeing the rows and rows of Christmas trees, for a kid, it's a magical time of year that you get to experience. Most kids only got to enjoy those feelings once a year, but I got to enjoy it every time that I visited my great-grandmother. What never occurred to me at the time is that the farm owners are longtime family friends. And I was having a conversation with the current farm manager one day. I think his grandparents grew up with my great-grandparents or something like that. So longtime friends. And when I was talking to him, the topic of my capstone came up. He mentioned that he'd been looking into using drones with the Christmas trees, and he wondered if there was anything I could do with that. And so I said I'd look into it. And one thing led to another, and here we are. So here's some quick background and quick stats about Christmas tree farms in the United States. There are about 350 million trees being grown on about 15,000 farms throughout the country. And these farms, they do exist in every state. They range from a few hundred to over 1 million trees being grown on one farm. It takes about 6 to 10 years for newly planted trees to mature to a height that is suitable for sale. There are two main type of tree farm operations. One is wholesale. They sell to third-party sellers, like the ones who you'll find in like the Home Depot parking lot selling trees and things like that. The other main type, one of the other main types, I should say, is to the public in a cut your own tree capacity, where people go to the farm, they find a tree that they like, and they cut it down themselves. 46 states do have cut your own tree farms, and I won't tell you who doesn't, just in case you don't want to know that your state doesn't. The ones that don't have cut your own tree farms, they do let people acquire permits to cut down their own trees in national and state forests. So in recent years, roughly 1/3 of Christmas trees that were sold were of the cut your own variety. And the farm at the center of this study does both, but the focus of this project is going to be on the cut your own side of things. Cut your own farms tend to be smaller, as the large farms, they have the infrastructure to be able to plant whole plots together. And then 6 to 9 years later, they'll just harvest the whole plots and put them up for wholesale. The small farms and the large farms have their own different sets of challenges, as you would expect. So, okay, here's a little look into what has been done and what is being done. As I was looking into that, it turns out there isn't a whole lot of published research specific to Christmas tree farms and remote sensing of any type. There's some scattered articles here and there. of people like doing various things around these farms. Like one researcher was using spot data to measure the shadows on Christmas tree plantations because there's the spacing of the trees is good for casting shadows and things like that. But nothing is really specific to the tree farms themselves. There are a couple studies that are being done currently by university agriculture extensions. One main one was at Michigan State, and the other main one that I found was at North Carolina State. I think there was one at Cornell and a couple other universities. But I was able to get in touch with the North Carolina State research team, and they've been really, really helpful. Some of our goals overlap, but there's enough differences that we're happy to cooperate with each other rather than feel like we're competing with each other and like trying to publish our findings first or all that. So they've been really helpful. That North Carolina State research is focusing on the large Christmas tree operations that sell wholesale. They've been looking at tree count, tree height, tree diameter, and plant health, and things like that, just as data that you can extract from the remote sense data. So far, they've been able to come up with those, but they're having a hard time with tree height. Tree height is proving to be tricky for them because Christmas tree species grow best on slope terrains, and the farms in North Carolina, as well as the farms here in Western Massachusetts, they have a lot of slope terrain. So I did find Michigan State's extension has been holding events to let Christmas tree farmers know what can be done with drones. They haven't returned contact requests, so I can't really comment too closely on what they've done, but I'd love to know just so I don't try to duplicate things. Outside of academic research, there were a few case studies I found, which are basically, advertising in blog form, saying about how trees are used, or sorry, about how drones are being used to count the trees and measure the heights. There's a LiDAR company that I found a great article about how they had flown a farm and had gotten some data. I contacted them and they said, yeah, it's a publicity stunt. They didn't do any quality control or anything like that. So they have a great system, but what they've done with it as far as Christmas trees are concerned is not really helpful for my research. So yeah, a lot of things are being done. There are a few things that are being done, but there's not a lot of reliable details, nor are many people really sharing their repeatable workflows. So it's kind of have a clean slate to do what I want to do. All right, let's get into what I will be doing. The Christmas tree farm is that's at the center of this project is close to where I'm living now. So that gives me plenty of opportunity to use the farm as my study area. And this is it. It's called Cranston's Christmas Tree Farm. It's a family-owned farm located in Ashfield, Massachusetts. They grow more than 26,000 trees on about 22 acres, and they do sell both wholesale to resellers and to the public in a cut-your-own tree capacity. They have 5 tree lots. 2 of them are dedicated to the public to let them cut their own tree. And they're planning to add a 6th lot, and that lot will also be open to the public. That 6th lot is highlighted here in yellow. So it's they've clear cut it, and it gives me a lot of opportunity to do a lot of neat things. So the Cranstons do grow 4 species of Christmas tree. They grow Fraser firs, balsam firs, concolor firs, which are also called white firs, and blue spruce. There's only a few blue spruces, and they kind of occupy their own small corner of the property. So I'm not going to really look too closely at that. But one of the cut your own lots is mixed between Frasers, balsams, and concolors, and that's the field where I'm going to be using as my study area, because the other cut your own field only has 1 species. So it doesn't provide a whole lot of variety for me to look at things. All right, some goals. Let's look at some project goals. After talking with the Cranstons and a few other Christmas tree growers here in the Ashfield area, I've identified 5 main goals for this project. Here's a quick list of them. I'll get into more detail in the next few slides, but I want to extract tree height. I want to do an inventory count by species. I want to monitor the plant health. I want to plan a new field for planting. And I also want to compare and evaluate systems that can be used to do these things. So let's look at what that means. For extracting tree height is very important to Christmas tree growers, because on the wholesale side, trees that are grown for wholesale must be tagged by height before you load them on the truck. Current measuring methods involve using a pole that you can see in the picture here that's marked in 1 foot increments, and that's you got to go to the tree and do that. The Cranstons tell me that if they knew how high the trees were before they go out into the field, tagging them would be a lot faster and a lot easier. On the cut your own tree side, it's also helpful for them to have a rough idea of how many trees of each height they have, like 5 to 6 foot or 6 to 7 foot and so on, before the season starts, so that they're able to tell people, what they have an idea of what their inventory is. So automatically extracting the tree height would be the most valuable piece of information that I could get out of this. But the tops of the trees, they're so thin that it's really hard to reconstruct them from photogrammetry, and even LiDAR returns may not be dense enough to really be impactful once they're processed. The North Carolina State's researchers have told me that they're having trouble accurately measuring the trees themselves. So we'll see how that turns out. I will talk about that a little bit more in a little bit. So the second main goal of this project is to do a tree inventory count by species. The farm keeps track of how many trees it sells each year in its cut your own lots, but it doesn't keep track of the species that are cut. And Seth Cranston, he's the current manager, that's him there. Hi, Seth. He tells me that the Frasers and the balsams are so similar that even they often have trouble telling them apart. So they don't really care about knowing the difference between them. Concolor firs, on the other hand, are a tree that a lot of people really like. And if you don't really like it, you really hate it. But several years ago, they noticed that suddenly a lot of people were buying the concolors. So they planted more than they had been in the past. And they tell me that it will be helpful for the farm to know how many concolors are being sold compared to the other two types, so that they can make projections about what they should be planting in the future. And on this picture here, the red circles are circling balsam firs, and the blue circles are circling the concolor, the white firs. And so they do come out differently in the imagery, which I was very happy to see because it makes my job a little bit easier. So. Yeah, another main goal of this project is to determine how effectively drone capture data can be in detecting and mitigating the disease. Right now, the farm staff, they physically monitor the trees by going to them. They can determine pretty quickly if each tree has a noticeable disease, since they've had so much experience with it. But they don't know if we're wondering if there's a way to find out that there's a disease is in such an early stage that you can detect it before there's visible results of the disease. So honestly, I don't have much at stake in this goal, but I got access to a nice, pretty multispectral camera to determine species. So it doesn't hurt to take a look at this and see how effective it can be. Luckily for the purposes of my project, the farm is planning to plant another field, and that gives me the opportunity to put together some mapping data like orthoimagery and elevation models to help them determine, one, how many trees can be planted, and two, where the paths between the rows should be, because the tractor has to be able to work the field, and the terrain in this area, there's some pretty steep patches that you don't necessarily want to be driving a tractor on where it might roll. So we're going to be able to look at that. And the final main goal is what I'm most looking forward to is that I don't only want to see what can be done, but what can be done in a cost-effective manner. My company works with a lot of drone service providers, and so we have access to some pretty good technology as far as the drone technology, the drones are concerned. And through Penn State, I can access some fantastic software as well. But these systems and the software packages are very expensive. And so these smaller tree farms probably are not interested in spending tens and tens of thousands of dollars on equipment and training and things like that. We calculated that the hardware I'll be using alone, not even including the software, is somewhere north of $60,000. And that's just not in the cards for someone who the farm only sells a couple $100,000 worth of trees a year. So it's just not worth it. So the final goal here is to compare data captured and processed with the high-end systems and high-end softwares with data that is collected by the budget drones, meaning cheap, and as much open source software as possible. And by open source, I definitely mean free. So that'll be fun to compare. So, all right, now that we've seen what I want to do, let's take a look at how I'm going to do it. I'm not going to get too deep into this slide. My proposed methodology just shows, hey, look, I have a methodology. The first method, like I said, it's going to be using two different systems. And the first method, which I've creatively dubbed method one, it's going to be done with the best equipment I can get my hands on. And that does include a LiDAR sensor and a multispectral camera. And the second, method two, which is very budget friendly, it's an open source whenever possible. It's going to be a good comparison there. I'll get into the exact specs of each method in a minute, but first I just want to say that the workflow for each method is more or less the same. I'm going to set out some ground control, I'll fly the drones and I'll capture the data. A quick note here is I will be capturing data before the season starts and after the season finishes so that I can do a changeover time comparison to track which trees were cut, which trees were cut by species, and how high they were on average and things like that. So yeah, I'll process that into initial data products like orthophotos and elevation models, do some object-based image analysis segmentation so I can get some shape files that I can then attribute attributes to and be able to manipulate them and get extract the data that I'm looking for. Then I'll be able to do some ground truth just because that's a good thing to do for an academic project, make sure things are right. And then prepare some deliverables based on the data that we want to be able to extract. So yeah, like I said, the workflow is the same no matter which sensors and softwares I use, but I want to do a quick look at the systems that I'll be using to do that. For method 1, which is the high-tech one, I'm going to be able to get RGB data with a DJI P1 camera that's mounted on a Matrice 300. The P1's a 45 megapixel sensor, and it's specifically designed for drone mapping missions. And the M300, we're also able to mount a L1, which is a 3-return LiDAR system as well. So I'll be able to generate elevation models from both photogrammetry and LiDAR data. And those elevation models, I'll be able to hopefully extract the tree height fairly accurately. I plan to capture multispectral data using a MicroSense Red Edge M. The Red Edge collects data in the RGB bands, but it also adds near infrared and red edge bands. And those will be helpful when creating vegetation indexes for things like species, determining species, and for monitoring the plant health and things like that. Method 2, I'm just going to use a Mavic Pro 1, which is also a DJI drone. You can get it used on eBay for I think like $600 or $700. It's a bare bones unit. It has a 12 megapixel camera that's not at all optimized for these high level mapping missions, but it's cheap and it could very well be sufficient for the work that these farms do. So on the data processing side of things, there's several software packages I'd like to use to generate the initial deliverables. There's a list here. The ones under method 1, they are proprietary and you do pay for them. The ones method 2, they're all the WebODM, QGIS, they're all open source. And so, yeah, that's, the basics are that the software is very different as far as pricing goes and theoretically different as far as results will go too, but that's one of the things that we are going to compare. So I just want to do a quick little note on some ground truth is that fortunately for me, this farm is close to my house. The purple circle there in the top right, that's my house. So I can actually look out of the office window in my house and I can see not a whole lot, but a few dozen of the trees. So nice and close, and they're family friends. They've given me free reign to go anywhere on the property and do anything I want. So ground truthing the data is going to be very doable. I expect that I'll be able to do, it's probably overkill, but I want to get 100 or 200 random samples for verifying the tree heights and the species. So that is something I am definitely planning to do. As far as the deliverables go, all the data can be contained really in 2 master polygon shape files of the trees, one for the first flight before the season starts and the other for the second. Attributes, there's a list of the attributes here, object ID, feature ID, some height values, some species index values, some like the name of the species and things like that. Was the tree cut between the beginning of the season and the end of season and things like that. So that will be very helpful to me to have those shape files, but for the farmers, they're not going to be able to use those. They don't have any background in GIS. So I'll be writing a report for them and as well for the capstone itself. Give them some map documents, give them some statistics about this is the number of concolors that were cut, this is the number of balsams and Frasers that were cut, where are people cutting them down, are people wanting the concolor, things like that. So as far as the new field is concerned, the deliverables will be map documents showing the field as well as estimates for the number of trees that can be planted and a slope map and a contour map perhaps so that the farmers themselves can decide on the best places to cut access paths and roads so that they can manage the property. So yeah, we have some challenges, we have some limitations that are going to be hard to overcome. The first one, like I keep saying, tree height is the most valuable piece of information that we can extract. And North Carolina State's team has told me multiple times, every time I talk to them, that they're having trouble with that and doing it accurately and consistently, especially since the leaders, which is the top of the tree that you put the star or the angel or whatever, they're very long and thin. And so based on my initial test flights, it's been really hard to construct those leaders in the photogrammetry software anyway. I think I found a possible solution talking with a farmer that they don't actually cut the leaders until after the measurements are finished. And so they measure to the last leader, which is a bit easier for the photogrammetry software to render. And then they just add a foot. So I'm thinking maybe if I just fly higher and try to eliminate the leader points altogether, then just add a foot like they do, I can come up with more accurate final measurements. But it's going to take a lot of playing to see what I can do that. So another problem that is in my initial flight, some of the smaller trees didn't even appear to be higher than the ground. You can see that in the bottom left picture here. The orange boundaries are polygons of what was determined to be a tree, and you can see it missed a lot. The grass was about 1.5 feet tall at the time, and so detecting those smaller ones was tough. We had a lot of rain this year, and the grass grew really fast, and there was no time to cut it. So just they happened to not detect the trees. I also didn't go out of my way to really clean up the inputs, since it was just a test to see if the idea is possible. But it's something that I'm going to have to deal with, and so we'll see how that goes too. One fortunate thing about this that the farmer tells me is that he doesn't care about the trees that are less than 5 feet high, but I still want to do a perfect job and make an impressive capstone and things like that. A final limitation that I have is that the data collection window is quite narrow. I prefer to collect the data after the first frost, so the grass is nice and dead, and brown, so that segmentation could be easier. But you also have to collect the data before the snow starts, because once it starts to accumulate, you can't get to the ground level data. Also, my business partner has all of our fancy equipment down in Florida, and so it's a matter of timing things well and making sure that he can be up here at the same time that we're able to fly, and then coordinating that with weather and things like that. On the other end, it works the same way, that I'll need to collect the data after the snow melts, but before the farm plants new trees to replace the ones that are cut over the season. And when will that be? We don't know. It's a late March or early April, but we can't exactly predict when the exact times that we're going to be able to fly. So, all right, I have some expected results of the goals that are determined by the farmer and me. I think that a species inventory of cut trees probably has the highest probability of success. The initial flights with my RGB sensor show that the concolors do pop out of the imagery, and filtering them based on vegetation indexes is pretty easy. I have to refine the parameters a little bit, but it should be pretty straightforward. And the species inventory of cut trees by itself, if that's the only success that I have out of this project, it still makes the project worth doing. So that gives me some wiggle room if I have trouble with the other goals of the project, like tree height, because tree height, like I keep saying, is challenging. I expect that the LiDAR data will be able to provide some solid information. I'm not sure about the photogrammetry results based on my initial tests, as well as what North Carolina State's team is telling me. And really, if it's going to be cost effective for the farmer, the photogrammetry results are more usable for them, because the LiDAR systems are so much more expensive. Plant health too, I think that's going to be hard to monitor even with the multispectral data, but especially if only using RGB data, since there's just so many species. I can see that maybe that might cause some problems having these multiple species. Fortunately, I was talking with a farmer just the day before yesterday, and asked him how many trees he usually cuts because they're diseased every year. And out of his 22,000 trees, he cuts on average about 6 trees because they're diseased or dead. So I'm like, okay, good. So it's not really going to be that helpful if it works. And so if it doesn't work, then it's not really a huge deal. Ultimately, the hope is that these low-cost systems will be accurate enough that these small Christmas tree farms will find using drones helpful without spending a whole ton of money. And yeah, hope that the low-cost systems work, because that would really really be helpful for not just the Cranstons, but a potential, I'd be able to make a guide about how to, implement your own drone program on your farm. And that'd be a nice little result of the project. So yeah, that's the basics of the proposal. One fun thing before we get to questions and comments is that, as life would have it, my parents wound up buying a house just down the street from my great-grandmother's old house. And my life's path took me out of Massachusetts to several other states and foreign countries before last December I finally moved my family back to the States after 11 years in Korea. And during, I was just driving my 3-year-old daughter to her grandmother's house for the first time. And since it's in the same neighborhood, we inevitably drove by that same Christmas tree farm that I used to enjoy. And as soon as she saw it, she just said, "Mommy, Daddy, look, it's a Christmas town." And just all of my childhood memories and emotions just came flooding back. And I got choked up that she could enjoy the same Christmas tree farm that I used to enjoy driving by as a kid. And so I hope that those memories for her are embedded so deeply that she will be able to enjoy those that same feeling with her kids when she gets when it comes to that stage. And if what I can do by making Christmas tree operations more effective using this drone technology and remote sensing techniques, that would be well worth it. I guess I will stop talking there and say, there we are.
Okay, great. Thank you, Nathan. That was a really nice, engaging talk. Really enjoyed it. I imagine you never imagined as a kid that you'd be flying remote controlled airplanes, taking pictures of these trees that you were driving by.
I never imagined as a kid that I would be an adult. So,
All right. So any questions for Nathan?
I have a quick question for me. Did it stop sharing because something seems to have frozen up?
Yeah, the share is done, but
All right, cool.
the talk was fine. Yeah.
Cool. Awesome.
So I'll ask a question. I know very little about remote sensing in general and next to nothing about drones. So I'm assuming that all of the imagery that you're gathering is essentially pointing down. Are you doing any kind of like oblique views of the trees? And I'm thinking of that in terms of trying to find the heights, if that would help.
I'm on mute. I'm sorry. My Zoom closed and then came back suddenly. So I missed the middle part of that question. Would you be able to repeat it for me? Sorry about that.
Yeah, sorry. I was just wondering if all the images that you're capturing are from pointing straight down, or if you're using any kind of oblique imagery to try to determine heights, tree heights.
Well, I have started data collection just to make sure that everything's working fine with some of the equipment, and for the orthos and things like that, they are pointed straight down. We're finding that we're having a better success with getting more dense point clouds when we do switch to oblique. So I will be probably using a mix of those. As far as the feature extraction for things like species, having better success with the nadir, with the straight down shots. So it's probably going to end up being a mix of those.
Okay. Looks like you've got a couple questions in the chat.
Yeah, I got a question. Rob says, Esri has a product called Drone to Map that has some capability to create elevation data. Yes, many of these products do have the ability to create this elevation data. I haven't looked at Drone to Map in too much detail. I know that it exists, but I'm pretty solid in my the software that we currently have, that I haven't really looked too deeply into it. But yeah, it's working for a lot of people. So good job, Esri.
Jim, let me clarify if I would this. The Drone to Map is a Pix4D engine, by the way. Esri contracted with Pix4D, so it's nothing really new from what we're using at Penn State, the Pix4D license. I just want everybody to know. Thank you.
Yeah, thank you, Qasim.
Sure.
And everybody, that's my advisor. I appreciate that clarification because I didn't know that as Drone to Map used Pix4D's engine, but it makes sense. So got another question here. It says, will the tree farm mow the grass this fall so that you have a better accuracy on the ground level? The answer is yes, they already have. When I did my test flights, they had not mowed it. And then they mowed it about I want to say 2 weeks ago or so. So the grass is cut. Unfortunately, they didn't do like right under the trees and stuff, but the data is coming out pretty well. So I'm happy with that. So we're able to get to ground better than we had in the past, and it's working out pretty well. So another question here came up. It says, have you tried any techniques to measure shadows of the trees for measuring techniques if you have a good base data? Actually, I'm doing my best to fly when there are no shadows. I'm using as many cloudy days as possible so that because the shadows do cause problems both with the feature extraction when you're doing, with feature extraction, and also when you process the data in Pix4D, the shadow pixels, if they're too dark, they're scattered all over the place. And there's ways to reduce the number of points that are produced from the shadows that are above the ground, but that also tends to reduce the number of points that are actually generated on the tree. So I, rather than going through and cleaning up thousands and thousands of trees, the point cloud of thousands and thousands of trees, I just figured it's probably easier to fly on cloudy days.
Okay, well, thanks, Nathan. That was great talk. Really fun topic. And best of luck with it.
Thanks.
So that takes us to our next presenter, who is Ashley Piccoli, and she's going to talk to us about logging activities and their effects on northern spotted owl habitat.
All right, can everyone see that?
Yep, looks good, Ashley.
All righty. Oh, there we go. So hello, everyone. My name is Ashley Piccoli, and today I'm going to be talking about logging in northern spotted owl critical habitat over a 9-year period between 2012 and 2021. So to give you some background, the northern spotted owl was listed under the Endangered Species Act in 1990. Section 4 of the Endangered Species Act triggers a critical habitat designation. And basically all that means is that the Fish and Wildlife Service determines, what habitat is critical to their survival, and then protects that habitat by prohibiting the taking of an animal. And the reason I'm using taking is because that's the exact wordage. But that basically includes killing, harassing, and modifying their habitat in a way that would force them to leave. Section 7 of the Endangered Species Act basically acts as a loophole that allows federal agencies to disregard Section 7 as long as they work with the Fish and Wildlife Service, tell them what they're doing, and the Fish and Wildlife Service approves whatever it is that would violate Section 4. And this is really important because northern spotted owls primarily utilize old growth forest for roosting and nesting, but deforestation is a major reason for their decline. In fact, it is the most major reason for their decline. And in national forests out west, where they are located, those forests earn revenue from logging operations on their land. So they kind of have to balance between the competing interests here of the owls and then their own revenue and the ability of the local economies to be able to make money. So my goals and objectives with this are to assess the amount and proportion of logging that has been done from 2012 to 2021 on Forest Service critical habitat land, specifically within their critical habitat zone. And then to assess which type of logging, commercial, pre-fire, and then post-fire salvage, has contributed most to a loss of habitat within this critical habitat boundary. And the 3 types of logging that I'm going to be talking about Commercial is exactly what it sounds like. You know, they sell contracts to contractors that will come onto the land and log trees. Usually, at least in this context of the spotted owl, it's going to be hardwood that's used mainly in construction and the kind of thing that you would find for furniture or to help build houses. It's hardwood, basically. Pre-fire is going to be logging that they do mainly to actually prevent fires. So to give an example, that would be like thinning tree stands so that if there are any fires, it won't spread as quickly, or to actually prevent them from catching on. And then post-fire salvage, it's kind of, again, what it sounds like. If there's already been a fire, the Forest Service and other federal agencies such as BLM, the Bureau of Land Management, may decide, you know, these trees are already dead. We might as well log them and clear everything out. So those are the three types I'm going to be looking at: is commercial, pre-fire, and then post-fire salvage, specifically within the critical habitat boundary. And so to make it even clearer why I'm studying this, it's basically because any decrease in old growth forest has been shown to have a negative impact on northern spotted owl reproduction and nesting. Also, because the critical habitat boundary was revised in 2012, and because there's a gap in literature where basically nothing post 2012 has been analyzed as far as logging on federal property within this zone. So it could be really helpful and useful in assessing basically the Forest Service's ability to balance and manage the competing interests here. And this is my study area. It's specifically within 3 states. So you have Washington, you have Oregon, and then you have Northern California. The red on this map indicates where the actual critical habitat boundary is that the Fish and Wildlife Service established. And I broke my methodology for this down into 4 different parts: data collection, the actual setup, quality control, and then the analysis portions of my analysis. So for data collection, I'm going to be using 4 different layers. You have the critical habitat boundary layer, of course, and then you have the national forest boundary layer, just telling me where actually is the property that I'm going to be looking at within the national forests. And I'm also going to have Landsat imagery that will be used for all of the years in questions from 2012 to 2021. And then I have a logging shapefile that the Forest Service was nice enough to post online. It's a very, very comprehensive layer shapefile, basically. The data in this logging layer, it goes back all the way to 1820. So when I say comprehensive, I mean there are thousands of polygons in this. So for the setup, basically setting up my analysis, I'm going to be using well, I've actually already done this part, but using the Mosaic tool in ArcGIS Pro to combine all of these images into one image per year, because there were hundreds when I tried to put all of the imagery from Landsat for all 3 states within this boundary. So I'm just going to combine them to make it comprehensive and easier to deal with. Then I'm going to clip all of the other layers to this critical habitat boundary because that is the only thing we are looking at here. I don't care if there's logging going on outside of this critical habitat zone. So I'm going to be clipping them all to that. After that, and this I've already done too as well, but spot checking the logging database against the Landsat imagery to ensure that everything that they put in there was pretty accurate. The logging data set, it was self-reported from the Forest Service, so making sure that they've actually during this time period been doing what they said they did as far as logging is concerned. That's paramount to ensuring that the results are pretty accurate. So spot checking that, and then also spot checking the critical habitat layer against the imagery to ensure and just double check that they're not roads, buildings, anything in the built environment that I'm looking at, simply because we only want to analyze what's going on the land, and that shouldn't be a part of the critical habitat layer to begin with. So, yep. And then for the analysis, I am going to add a column in the attribute table of the logging layer and reclassifying all of the projects into commercial, pre-fire, and then post-fire categories. Then separating the projects by year using a SQL statement, saving them as separate layers. And that will help me sort through the thousands of different polygons and only get the ones from 2012 to 2021. But basically saving a different layer with only, you know, the logging that's been done for one specific year. For all of the 9 years in this study, we'll have one layer per year for the logging. And then opening the table, extracting the area measurements from these attribute tables, and also from the critical habitat layer. And from that, it's a quick and easy calculation to, you know, figure out what the actual percent logged in each year was, and then the percent for each specific category of logging. And after that, you can pretty much average it over that whole time period to determine which category of logging has contributed the most to a loss of habitat for the northern spotted owl during this time period. So for the timeline, I've already done part of this. I've gotten through the quality control section. I intend to do the non-peer review portion of 596, so the B section, in spring 1 of 2022. So by that point, I want to have the analysis portion done. And by February, I would like to have my final paper written up and hopefully presented if we are still allowed to do Zoom. But if not, there's a Towson University GIS conference that they have every year, typically in the late spring to early summer. So I could do that if, or both, you know, I don't have to stop at one necessarily, but I do have a backup. And then for the anticipated results, what I'm looking at is specifically, I would like the acreage and then as a percent for each year of the pre-fire, post-fire, and commercial logging. And then also just the average for each of those categories over the entire study period. It'll be really interesting to see what the results actually are, just because over the past 40 years, based off of the research that I've done, major fire events out west have significantly increased in frequency. So I'm wondering if there might be any increase over this time period. And especially lately, there have been some fires where it might be interesting to see if there are any outliers because of them. If any of you remember the Dixie fire that happened somewhat recently, it's only about 95% contained at this point, and it ravaged part of Shasta Trinity Forest from what I remember, and that is part of this study area in the critical habitat boundary. So looking over stuff like that, there were the bootleg fire too, I think was last year. It'll be interesting to see if there's any outliers with that, just because, you know, with the post-fire salvage, they might have come in afterwards and done a ton of that. And also to prevent further fires, they might have logged there. And then the other thing that I thought it might be really interesting to see if this has any effect on the different harvest rates, but COVID happened. And I don't know if any of you have developed any new hobbies during COVID, but apparently a lot of people have done home renovations because they're already home and they have time. And just the desire to focus on something other than COVID. So a lot of people have been going out and buying construction materials to renovate, or also just completely buy a new house. Especially if you have a large family and everyone's at home in a cramped space, it can be a little much for some people. So there has been an increase in some logging that has happened, and also the demand for logging has gone up. So that also with COVID though, you know, you have people getting sick and quarantining. So it could have had an effect on that too, with operations being temporarily closed. I know that the Forest Service actually extended contracts for a lot of people in the area that I'm specifically looking at because of COVID, and also extended the hours that they can log. So I may see an increase in the amount logged in 2020 and 2021 because of COVID. And the significance of these results would be basically when you determine what type of logging is being conducted and to what extent, it could have an impact on what management strategies are best suited to protect the habitat for the northern spotted owl, and what can be done to, you know, help with this human wildlife conflict. Basically, if pre-fire logging is a very big source of the logging in general that's been going on, for instance, they might want to try prescribed burns, preferentially over thinning. Post-fire salvage too. There have been studies done on the northern spotted owl, and as it turns out, fire doesn't have a huge impact on mortality rates for them. It can actually increase their reproduction rate, believe it or not, but logging certainly does. So maybe just leaving the burnt trees there in the environment. And commercial, obviously, you know, trying to target people and these contracts with the contractors in other areas if possible. So it basically just determines what I end up finding with this, what people could do with it. And there are my sources. Any questions?
Thanks, Ashley. It looks like you've got a question in the chat from Rob.
Oh, there it is. Okay. Have you looked at how different types of harvest methods may affect this? Clear cut versus high grade. I did, and it does to an extent, but only to an extent. Each different type of harvest method still had a significant effect on, you know, spotted owl mortality and then their reproductive, basically their overall fitness.
other questions for Ashley?
I know I still have a bit of time here. I apologize. I thought I would not have blown through it so quickly, but
Well, if you-
Actually, this is Steve McKeag. I just had a question. Do you have comparative data on the increase in the wildfires that have affected the forest? Because obviously we've heard so much about the California fires and spreading up into Oregon and Washington State as well. But have you got temporal data that would suggest there's more of a factor from that than other kinds of disruptive events?
So when you say comparative, you just mean more of I'm just trying to figure out what your question is here.
Yeah, so the accumulation of fuel at the forest floor, a lot of people have said has increased the incidence of wildfires, and they become more severe, a lot greater property loss, habitat loss, and things like that. And I didn't know if you had data to compare the number of fires in any given year over the area of your study compared to more recent years, or if that's going to be part of your metrics in your data.
Right. So over this critical habitat area, no, not specifically over those 3 states in particular. Yes, I've looked at the incidence of fire. I've actually looked at a lot of studies on that. It's hard to determine because some of this information isn't really publicly available or not as available as it should be, how much they've been logging due to the fires, either, you know, to prevent them or afterwards. I know that it's only one kind of management would be the thinning and forest floor cutting basically of the different layers there. So I don't have anything on that specific area. Overall, I have a general picture of what they've been doing, but nothing that I can, because it does vary too, depending on where you are and what the actual biome is. You have places in some parts of California that are vastly different than what you would find in Washington, even within this zone. So it's hard for me to draw any conclusions just based off of that. And, you know, more specifically with their general management activities that have been done related to logging in relation to the fires. If that answers it.
Oh, yes, thank you.
Ashley, I was interested in how this, in whether are there studies that the National Park Service or National Forestry Service has done, and I think there are probably some very large commercial logging companies out there. Have they done studies like this that, you know, because I mean they wouldn't want to get into an area, you know, or buy or lease an area of land and then realize they can't cut, you know. And so I was just trying to think, are there other, you know, people or other organizations that would use this study or have already been doing some of these types of studies?
Right. Well, the Forest Service overall could definitely use this, and I think that they are very open to considering every bit of information that they can get. The last study that was done that I could find on logging and just general habitat loss within this zone was done by them. It was actually completed in right around the time that this boundary got revised, but I haven't seen them do anything since. And I think it's because you need more than, you know, 1 or 2 or 3 years worth of data to draw conclusions from it. As far as the private industry is concerned, this is where their listing got really controversial. just because there's a lot of logging that goes on out west, and deforestation was kind of the issue here, and nobody wanted, it's like a game of musical chairs, you know, nobody wanted to get caught with the land where they couldn't use it. But there have been a lot of exceptions made. So even on private land, there's still logging done within this critical habitat zone. I think they have exemptions that they can get to. As far as data is concerned with them and what's publicly available and with them doing their own studies, what the Fish and Wildlife Service has said is that they do collect information, but they don't make it very publicly available. I've actually gone to the websites and I've emailed a couple of people about just getting a general idea of what's going on. They don't like telling people how much they're logging in spotted owl territory. I can't say that's really a shocker, just because it probably wouldn't look that good for them. And the other thing too is that part of this habitat falls on tribal land, and they have done some studies and they do want to try to capture as much information as possible, but this critical habitat zone, it contains about 24 million acres. And so there's about 20 different tribes that have land within this zone, and it's kind of hard to get a cohesive picture from them as far as what's going on, because they all run things differently, so to speak.
I know I've run into difficulties getting data from like government organizations. Sometimes I'll find that they're very cooperative, and then sometimes I won't be able to get anything or get anywhere from them. And I've had to actually put in like public information requests, you know, formal public information requests in order to get the data. So I don't know if that's an option for you, but I just, you know, thought I'd mention it.
I'm surprised that they made the logging information as publicly available as they did, but you're right. I actually tried to email the Fish and Wildlife Service just about the critical boundary layer to get an idea of what went into them drafting it. You know, it took 4 years and they studied about 44,000 different owls to get the boundary that they did, but it was very unclear what they actually did and what went into that determination. So I tried to email them, and I actually tried to email a couple different people, and those addresses bounced back. Like they didn't even work there anymore. And this was stuff that was on the federal government's data clearinghouse too. So I don't know, but their points of contacts are definitely not updated.
I have a question, Ashley. So I'm not that familiar with owls, but I do know there's a lot of organizations for conservation when it comes to, you know, waterfowl and things like that. And so you have, you know, different regional organizations, and then you have the national ones like Ducks Unlimited or National Wild Turkey Federation.
Yep.
And all of them have huge GIS gaps, but they also, I mean, among them probably own millions of acres throughout the country. I think Ducks Unlimited alone is a few 100,000 that they own. And, you know, it's not owned by a government, so it's not being sold out for purposes, and it's just for habitat preservation, basically. Are there organizations like that that, I mean, for the northern spotted owls, or are there organizations like that that might benefit from your study?
I think that there are definitely NGOs that would benefit from this, particularly if any groups such as, for example, Defenders of Wildlife or WWF or anything like that want to push the Fish and Wildlife Service to further revise this boundary to make it bigger, because there is a need for more habitat for the spotted owl. If my analysis shows that they've lost a significant amount of habitat due to all of this logging, or if there's any NGO that would basically want to try to pressure them to change their management strategy, something like that, they would certainly benefit from this.
Or again, even if there are NGOs who could create their own habitats outside of the logging areas, maybe.
You're right. From what I saw, I looked at all of the different entities that are within this general area and the critical habitat. And it looked like there actually weren't that many NGOs or anything like that, private entities that are related to conservation that have set aside significant amount of lands. So that could actually be a good strategy going forward, is transferring land. And it doesn't necessarily have to be from the Forest Service, but right around this boundary or from different private entities into the hands of NGOs, conservation entities that wouldn't have their coffers in the pockets of logging, basically.
Okay, well, we are at 1:30, so it's time to move on to the next speaker. Thank you, Ashley, for a nice talk. I wish you the best luck on your analysis and finishing off your capstone.
Thank you.
All right, so yeah, our last speaker for today is Rob Ford. Rob's going to talk to us about locating, looks like fire trucks in Columbus, Ohio.
Hi, can you guys see my screen now?
Yes, I can see it. Looks good.
All right. So yeah, as you said, my my project is locating Columbus fire rescues and ladders. A little bit of a background. This project is for work, actually. I'm a GIS analyst for the Columbus Division of Fire. We respond to about 160,000 emergencies a year to make sure that these fire stations and vehicles can respond as quickly as possible. We need to be able to plan ahead of time using historical data and trends and demographic data and things of that nature. So this project looks to find exactly where two types of vehicles should be placed, rescues and ladders. So what's a rescue? What's a ladder? A rescue is this vehicle you see here in this bottom left picture. They contain the jaws of life. They don't have any ladders usually, and typically no fire hoses. And they're primarily used for technical rescues, which are things like people trapped in cars and water and machinery. But we will also use them on high priority medical calls if no one else is available. So things like cardiac arrests, strokes, trauma type things. But primarily they're used for rescuing people. A ladder, on the other hand, is a very expensive, very large, the largest vehicle that our fleet owns. It also has the jaws of life, but it primarily has a giant ladder and water hoses and is basically used for fighting fires. Also, they're used for rescuing people in high places and people trapped in cars because they do have the jaws of life to help break open cars and things of that nature. So a little bit about Columbus. Here's a population density map I made using the American Community Survey estimates for last year. The dark blue area there in the center of the map is actually Ohio State University campus, and they have a lot of high-rise buildings for dormitories, and so that's why that population is so astronomical there. So where are these vehicles and where are all the fire stations at? So right now we have 16 ladders and 5 rescues. You can kind of see how the ladders are kind of concentrated. This is the downtown area here. So there's a lot of skyscrapers and things like that. The rescues, on the other hand, are kind of spread out. They typically would like them to be responding to more auto accidents and things that require those jaws of life. And so they're kind of in these pointed areas next to these interstates. So where are they responding to? I took 3 years of data and made these heat maps. You can see the ladders, not a big shocker. A lot of their emergencies are in this downtown area here or Ohio State University, which also has quite a few high rises. For rescues, they're kind of more sporadic. They since they do travel on cardiac arrests and things of that nature, this is kind of an area that's a little bit worse part of town where there's a lot of those types of things happening. But yeah, you could kind of see if we go back to the population map here, station 12 and 17, 15, 8. That's kind of where some of these hot spots are on these maps. So shocker, emergencies happen where people live. The very specific goal of this project is to show the best locations for New Columbus fire rescues and ladders that minimize response times and most efficiently apportion potential future 911 calls. So I did a little bit of digging and literature to see what other people have been doing to basically figure out where fire stations should be located, and that I can essentially kind of apply what I've learned through these papers to vehicle placement as well. This particular paper created a gridded suitability model that used soil types and distances to various points of interest, things like educational buildings, hospitals, shopping malls, cultural facilities, to basically figure out which grids. I think they used a 120 meter grid size, but basically figure out which grids would be most optimal place for a fire station. This paper, they used hotspot analysis to predict where 911 calls would be based on historical 911 data. So they use stepwise linear regression, geographic weighted regression, demographic data, and then distance to urban center and some other various variables to put into these regression models. This particular paper used space-time pattern mining tools that ArcGIS Pro has to basically try to figure out where in space and time are certain emergencies, in this case, traffic accidents involving elderly patients, where are these happening? And so they use emerging hotspot analysis, which is a tool in ArcGIS that essentially uses the Geddes or G-star statistic to calculate Z-scores and basically measures the intensity of clustering. And so you can kind of see these red areas show that these are clusters of traffic accidents with elderly patients in them. They also had access to point traffic data, so they were able to really get into it. They didn't have to rely on aggregated data. They had access to the raw incident data. And the final paper I'll show you, this is a paper out of India. They wanted to figure out where fire stations should be placed. And so they actually ended up using or showing service areas using the network analysis tools in ArcGIS. In this map on the right here, basically shows where the gaps in coverage are at. I think their time here was 5 minutes. How far can a fire station get in 5 minutes? And so this kind of identifies the gaps here, these white areas. And so they actually created a model to figure out where potential fire stations could be placed using soil types and kind of similar to that first study I showed you. But then they decided to see where, using basically the centroids of certain polygons that they have here, what the best locations would be to basically minimize response time. And so this is using location allocation tools in ArcGIS. This looks like straight line distances, but this actually is distance based on a road network that you create in ArcGIS. ArcGIS just kind of spits it out in a straight line distance format to make it easier on the eyes. But you can kind of see here they've decided to put this fire station right here where this kind of gap in coverage is, and then obviously a few around here or on the outer part of the city. So what am I going to do for my project out of all this literature research? I'm basically going to combine all of these things for the emerging hotspot analysis and space-time pattern mining tools. I want to use those tools to show where rescues and ladders have gone in the past and where those types of emergencies that they respond to, traffic accidents and fires, where are those increasing the most over time? So the emerging hotspot analysis that actually uses nearest neighbor analysis, type of point pattern analysis, and the local outlier analysis is similar to emerging hotspot, but it's using the Anselin local RANS statistic, which also gives a z-score and indicates clustering in a slightly different way. For network analysis, they have actually two different types: minimize weighted impedance, maximize coverage. Those minimize weighted impedance is a way of saying minimize workload per vehicle within a certain time cutoff. For Columbus Fire Department, our standard is 8 minutes. So pick the best stations that can respond to the most incidents within 8 minutes. Maximize coverage is another form of this location allocation tool, a different model type that finds the locations where the coverage area is maximized within that same 8 minutes. So point pattern analysis, I'll be doing nearest neighborhood analysis with the emerging hotspot and local outlier. But then for regressions, I'd like to do geographically weighted regression. Essentially, my dependent variable would be the number of 911 calls at a certain location versus some of the other variables that I'll get into later here. Some other considerations: the unit of observation is accessible location for a vehicle. So in our 911 system, when you call 911, we automatically get the latitude and longitude of where you're calling from, provided you have a good signal. And so that actually gets snapped to the nearest point of interest that we have in our system, which is address points, street address points. And so in this case, this park here, we only have a few address points here. And so if you were to call and say, you know, help, I saw a car go into the river here or something like that, you might get snapped actually to this point. So the emergency didn't actually happen here, it happened over here. So the 911 location may not be the exact emergency location. This example here is mile markers, bridges, and on-ramp and off-ramp accessibility. So the same sort of thing would happen on a highway. If you were to get in an accident here, you would get snapped to the nearest mile marker or bridge or on-ramp or off-ramp. And so I kind of need to explore nearest neighbor, fixed distance, different types of analysis to kind of account for that. Another issue for us being such a large city, we have a lot of large parcels where there's not a lot of stuff going on outside of a certain building. So one of these examples is our airport here that you see in this map here. So there's a lot of emergencies occurring right here, but this entire, you can kind of see the outline of the parcel from the Esri base map here. But this entire parcel might look blown up if I were to look at things, you know, at that scale, because there's only address points along the road here and not, you know, for the tarmac, the actual field areas here. And so we have that sort of thing happening with large industrial parcels, things like train yards and stuff like that as well. So the modifiable aerial unit problem kind of comes into play here because the city of Columbus actually partners with other municipalities. We have different agreements with where we can respond and where we can't respond and things like that. And so there might be absence or presence of data based on these business practices that we have. Another thing with the emerging hotspot tool, you can summarize things in grids, and a lot of times people use hexagonal grids. So you can actually run into issues with that. Back where I was kind of showing you the this problem here, where certain hexagons may contain this particular point, which makes it look like a very high value when it's just one location versus another one that's next to it. Using nearest neighborhood analysis, it might look like a cluster, perhaps low or high, but that might be a little bit erroneous if you're trying to look at spatial patterns. But I do have access because I work with the database and stuff. I have access to the exact latitude, longitude points, so that kind of helps a little bit get around some of these issues. So the data that I'll be using is the National Fire Incident Reporting System, incident type and property use, 911 data, whether a ladder rescue was sent and what types of emergencies, parcel data, land use type and property value, and demographic data. So here's some examples of the National Fire or Incident Reporting System, or NIFRS is what we like to call it. So you can see there's different types of property use codes, over 156 of them to choose from. For incident types, there's over 179 specific codes that our firefighters will use to describe an emergency once they're done with that emergency and fill out their reports. And so it's very detailed. We can go in and see whether the auto accident in this particular series, auto accidents, can be categorized as with injury, without injury, with a motorcycle, with injury, very, very specific. Our 911 information, it has call types. So when somebody calls 911, the call taker tries to figure out the best response and what the actual emergency is based on the information you're giving them over the phone. I can tell you how fast these trucks are responding. Again, it has to be within 8 minutes. That's our standard of cover. I can see what other types of vehicles were dispatched, but in this case, we're just worried about rescues and ladders. I'm also only getting 3 years of data. I have access to much more data, but we have changed our business practices for certain how these rescues and ladders respond to certain call types, and so that kind of affected the data any further back. There's huge decreases in certain call types for rescues, for instance. So I'm only getting 3 years max after we made that business change. For parcels, we actually sprawl into 3 different counties that have 3 different schemas, but they all have these 4 data points at the very least: a unique identifier, land use type, building, and land value. So these are kind of the independent variables that I'm trying to use to model where these 911 calls might be later on, including demographics. So we have access to redline boundaries, the American Community Survey data I showed you with like the population density. When the census comes out, if they start coming out with more data, I might be able to use that. We also have the city of Columbus has an enterprise agreement with Esri, so I have access to all of the business data that comes with that agreement. So things like expenditures for health insurance, or alcohol consumption and things of that nature. So maybe alcohol consumption is correlated to more traffic incidents in an area, for instance. So my expected results are to build a story map or dashboard of sorts that would describe these findings. It would contain maps and filters to let people explore, and it's it's really important for me to make this as easy to understand as possible and explorable as possible, because my audience for the end result is my administration, because they want to see where more of these types of vehicles should be placed. So this example here is something that I made for hazard scores for the county. And so you can kind of see each station and how many parcels are in it and things like that. So I would really like to be able to build a dashboard or a story map that kind of walks them through the findings. So the timeline, I already have all of the data that I need. The deciding on the spatial methods, I showed you the methodology with the space-time pattern mining tools and the network analysis. And so going forward, I actually want to perform all of these methods, and eventually by beginning of next year, I would hopefully be able to start creating these visualizations and a final report to submit to our administration. And so, yeah, I'm really excited to dig into this. And is there any questions?
Robert, something that came to my mind during the presentation is sometimes things like this could turn into an evaluation of like the other locations, like the other the other fire stations. Yeah, is that possible that this could highlight whether or not, you know, a fire station cannot respond in time or is not as effective, and maybe it's not even their fault, maybe it's just the characteristics of the city that would prevent them from being able to respond?
Yes, so that's another thing they would like to identify, you know, maybe in this map up here. Let me get back to it here. This map here with the fire stations, they could say, okay, these station 16, for instance, for some reason is picked as a spot for a ladder because ladder 13 here is actually performing very poorly. And so that could totally basically highlight where actual fire stations are having issues.
Would that cause people to not want to accept what you're doing if you're highlighting, you know, where certain fire stations can be deficient? Would that cause people to not not be happy with seeing something, you know, a study like this?
Definitely. They've done similar studies in the past. I know another project that's an aside to this is very similar, is where to put new fire stations. And so they've been replacing old ones and moving some of them here and there, so that they're kind of used to receiving bad news, if that makes sense.
Before we take more questions, I just wanted to make sure everybody sees or thinks about filling out the peer review form. I inserted the link to that again here in the chat. Please make sure you do that for as many presenters as you can. It's really valuable feedback. But other questions for Rob? Looks like Ashley pointed out in the chat that her roommate's father used to be a fire chief, and they had GIS personnel doing similar work.
Oh yeah, yeah, I know. Going to the Esri conference a couple years ago before COVID was great, and they have an entire public safety area in the convention center there, and it's great to interact with the other entities and kind of get ideas from them.
Yeah, I agree with Katie. Thank you for what you do.
Oh yeah, no problem. it's fun.
Yeah, I bet. I bet. Any other questions for Rob? That was a really nice presentation. It's great to see the technology used by entities like the city of Columbus, and looks like they've got a really good resource working for them in you, Rob.
Thank you.
All right. Well, if there aren't any further questions, yeah, it's been a long, long time. I think it works out to pretty close to a Lord of the Rings movie, and equally as engaging, right? So great job, everybody. Today, 7 of you. Wish you all the best of luck, and we'll be back to do some more peer review presentations on Monday, I believe. So everyone have a great weekend. Yes, less bloodshed. That's right. All right. Take care, everybody.
Thank you.